Hello, friends. Welcome to Coding Garden with CJ. Welcome to, what is this episode? Intro to hardware. Open source hardware, Arduino, and we're going to learn how to program it. It's going to be fun. Welcome, everyone. I have here an Arduino. We're going to talk about what it is. We're going to program it. It's going to be fun. But let's say hello to everyone before we get too deep into it. Hello, Joundi. Welcome to the stream. Hello, Cyanton. Hello, Client Telephone, who is very much into today's topic. That's good. Hello, Auka. Hello, Vicus. Hello, T-Card. Hello, Mark. Hello, Domenico. Hello, Abby. Hello, FreeDebugs. Mark is asking, does anyone know C++? I know very little C++, so we are going to use C++ today, but Arduino programming is actually very easy with C++, for the most part. I do have in the title that we might use JavaScript, so we'll see if we get there, because there's this thing called Johnny 5, which lets you control Arduino with JavaScript, but it has some limitations in that it won't work if we unplug the USB, but we'll talk about that, yeah. And hello, Zuhaib. FreeDebug says, I'm the solution for their second monitor today. That's fun. That's the trolled emote, nice. Hello, Proxin. Hello, Alka. Hello, GamerCat Neko, or Nico. Welcome. Welcome. Hello, Tom. Hello, Greg. What's up? Hello, Marco. Hello, Mark. Win320 days says, I've been waiting for this topic for so long. That's a really cool Twitch name. Great work. Great work. And hello, Gabriel. Hello, Bivin. Hello, Tom. Hello, Cananello. Hello, Branjal. Hello, Vouter. Hello, Meta Tom. OMG Arduino. Yeah, it's gonna be fun. And like in the title, as it says, this is the basics. We're gonna do what's up, Bob? We're gonna do intro stuff. So I'm gonna show you like the basics of a breadboard and how this thing works. We've got some LEDs, so we're gonna light those up. I've got some 7-segment display and also like an LED display that we might mess around with. Lots of goodies in store for today, so it's gonna be fun. Win320 days says they know C++, so you can ask them for questions. Hello, Bob. Yeah, Johnny 5 is pretty cool. FreeDebugs is asking, is that how the top of my table looks like? No, I just have like well, it has measurements on it. It's got a grid, and it's 23 inches by 17 inches, and I just have it right there. It's nicer than like the fake wood countertop that I have. Nice. Win320 day is an 81% student in C++. Hello, Monkey Martin. Are you talking about Flexbox? We know Flexbox around here. And hello, I am. Hello, Jan. But is drinking beer illegal in the U.S.? No, but certain states and really certain cities have laws that say things like you can't buy beer on Sunday, or you can't, or any kind of alcohol. You can't potentially buy alcohol after a certain time at night. Different cities have different laws around that. But for the most part, drinking is legal. You can do it. And then, what was I going to mention? Oh, and then some cities have laws where they only sell beer. They're like certain only sanctioned places can sell like liquors and like high alcohol content things. But grocery stores can sell beer. And for a while here in Denver, grocery stores were not allowed to sell any alcohol at all, but they recently changed that so grocery stores can sell beer now. And it used to be that grocery stores could only sell beer that have like 3.2% alcohol instead of the regular amount. I don't know. It's legal. Some places have weird rules and laws around it. Hello, Jonas. Welcome. Abby says, I have an unused Raspberry Pi. This is good for me. Yeah, so we can talk about in a bit, and remind me, you can ask the question later, like what's the difference between an Arduino and a Raspberry Pi? And we can talk about that. But a lot of the things you can do with an Arduino, you can do with a Raspberry Pi. And the cool thing about a Raspberry Pi is it's a full-fledged computer, so it can run node.js on it. It can run, like, it's Linux. You can run anything you want on there, and you have a general-purpose input-output, which is what these things are. So, Arduinos are really cool. I'm sorry, Raspberry Pis are really cool. And some of the stuff I'm showing you with this, you could do with Raspberry Pi as well. And hello, Julian. Hello, Bob. Hello, Majestic Eye. Hello, Fluke. Greetings from South Africa. Welcome. Yeah, and YouTube is working today. Pranjal says they used a breadboard in second semester in college. Yeah, me too. So I got a computer science degree, and one of the classes I took was digital design. And in that class, I learned all about like the basics of circuits, the basics of logic gates. So yeah, that was really fun. That's a great emote. I think Alka made it the other stream. Whenever I got trolled. Is that Elon Musk? Oh, wow. That's nice. Stair Home says, have an Arduino in their window that they stole from school. Cool, yeah, and I'll talk about, these things are cheap. So, the official Arduinos are probably like 20 or 30 bucks, but it is open source hardware, so literally anybody can take the schematics and build one of these. So this one right here, I paid like $9 for on Amazon. And there are a lot of different like off brands that you can get. Hello, Magic Fire. All right, we'll save this question. What's the difference between an Arduino and a Raspberry Pi? And remind me to answer it. Oh, hello, Greg. Yeah, this isn't a fish. This is an Arduino. Oh, yeah, in terms of the alcohol question that was asked earlier, the legal drinking age is 21. In certain parts of the United States, you can, if you're with a parent and you're over the age of 16, you can order alcohol. But you must be 21 to buy it. And like I said, the different states have different laws around it. Yeah, so Raspberry Pi is a full-fledged computer. This is a microcontroller. So this little chip right here, it has a single purpose. It can do only one thing, and it does that one specific thing that you program it to do. Whereas a Raspberry Pi is literally a computer, so you could have multiple programs running on it. But yeah. Why drink beer when you can drink iced tea? I agree, Gabriel. Oh, thank you, actually, Walshy. Appreciate that. We can wait for it to ride before start. If you use Amazon Prime now, and I'm going to show the basics, which I'm sure you can fly through if you missed that. But yeah, if you have Prime Now available in your area, get yourself an Arduino. Why not? Yeah. What's up, Wings in the Sky? Yesterday I showed my video where you jam with your friends and use Google Kit to build Assistant. Oh, nice. Yeah, I'll mention that really quick because that was a fun little like hardware hacking day that me and my friends did. If you just search for Coding Garden Raspberry Pi. This thing, yeah. And this is like one of the few edited videos on my channel. Yeah, we got together one weekend and everyone brought their hardware and their Raspberry Pis, and we just tried to make stuff with it, and it was super fun. So that video is pretty cool. And hello, Sujan from Nepal. Welcome. Oh, Majestic Eye was the one that clipped it. Nice. Did you like accentuate my mustache? I feel like, or is that what it looks like when I go to that angle? Can you go 4x? No. Can I go 3x? That's funny. Yeah. So what we're gonna do initially, and I'll go ahead and talk about it, is first we're just gonna talk about what is this thing. I'll show you the basics of a breadboard, and then we're gonna get an LED to light up. It'll be lit up all the time. And then after that, we're going to write a basic program that will blink the LED, so it can turn the LED on and off. And in between that, like not exactly in that order, we're going to talk about resistors, these things, because for our LEDs, we're going to need a resistor. And so we'll talk about that and all that good stuff. So that's the basic plan. And then after that, I'll probably put it to a vote. Because there's a lot of different cool things we could do. We could hook up one of these 7-segment displays or one of these LED display, 8x8 LED display. I have a relay, so we could potentially turn a light on and off. I have a ton of different sensors, so we could do something whenever something comes in within a certain distance. I have a like ultrasonic sensor. I also have like light sensors, so it's basically like motion detection. Look at that. That's great. We can do something when it detects motion. Yeah, so that's the plan. There we go. There's an Arduino link from Client Telephone. Very cool. Some Pro Minis for about $1.50 each. Like a Raspberry Pi Pro Mini? Or you mean Arduino Mini? I don't know what you mean by that. Fluke says, I used a Raspberry Pi camera and 3G chip along with a solar panel and battery setup as a remote camera setup. It stayed alive for 3 years unattended. Yeah, that's awesome. So that's the other cool thing about Raspberry Pi, especially the more recent versions, is they have Bluetooth and Wi-Fi built into them. In this case, they use 3G, but if you wanted to use Bluetooth or Wi-Fi with an Arduino, you would need a special shield for that, which costs almost as much as the Arduino itself. And And I mean, technically, you could plug an Arduino via USB into a Raspberry Pi and then use something like Johnny 5 and control it with JavaScript, but I don't know. Yeah, I don't have any monetization enabled on Twitch. That's the reason I'm able to stream on both YouTube and Twitch at the same time. Oh yeah, get one. It'll be fun. A Flappy Bird on an LED matrix showing different images. Oh, that's awesome. Let's check it out. You have any pictures? That's pretty cool. Yeah, we could do something interesting. I was just thinking, like, with this thing, we could make it show like a smiley face or something like that. Yeah. Alka has a bunch of LEDs, wires, ICs sitting in a box. Yeah, you should get one. Get one. And hello, Abdelhamid. Hello, Maroof. Hayes is saying, I use Arduinos to make MIDI synths and controllers. Yeah, I have a friend. Well, actually, if you've watched Coding Garden for a while, I used to do this thing called Newbie Tuesday with a guy named Tony, and he's super into synths. And I told him about Arduinos, and he learned all himself, and he made like a box with a bunch of what are those called? Knobs, but they're not like there's a name for it. The thing that can rotate like from 0 to 10. So he put a bunch of those on there, and that controlled the circuit, which then he could he soldered an audio out to it. Pots? Are they called pots? Yeah, that's what yeah. Potentiometer. Yeah, in the guitar world, we call them pots, but the real name, I guess, is potentiometer. Yeah, that's the word. But yeah, so I can control a value. We also could potentially use a potentiometer. I think I have one to control like the brightness of an LED, potentially. I don't know. We'll see. But yeah, this is fun stuff. Oh, okay. And hello, Srilo, welcome. Hello, Krisu. I can't believe that was just a normal face you made. I think somebody trolled me and I was mad. But yeah, hello, Ben. Hello, Lars. Resistors and diodes really confuse me. Cool. We'll talk about resistors. That's probably the easiest thing to understand, I think, in terms of like, once you start branching out, I mean, that's one of the first electronic things you're going to come across. But yeah, we'll talk about resistors. And actually, we need to calculate the resistance of these to find the right one. And you can do that using the color, so we'll talk about that too. Yeah. Please visit India once. I might. Not anytime soon, but eventually. If we do use JavaScript, we will use Johnny 5. That's the plan. Yeah. Hey, what's up, Doc? It's been a while. Welcome. Hello, SM. Stern Home Dev says, we have a full classroom dedicated to Arduino stuff at school. You can just steal from there for projects at home, and our teachers even recommend us to do it. That's awesome. Yeah, in at least where I live in the US, almost every public library has a hacker space where they have soldering irons and 3D printers and places where you can build stuff with Arduinos. And the reason I'm doing this stream is last weekend I actually taught high school girls how to solder and how to program the Arduino for an organization called ChickTech. So this is a nonprofit that teaches young women about science and technology. And so I did a workshop where we built robots. And that's potentially an option for something that we can do after I go over the basics. It's not that fun, though. I think it's cooler to do like LEDs or something like that. And Raoul is no longer on the skateboard scoreboard. Alka's on the top, though. 98 point. Is that 96? Cool. Bob says, I took an embedded systems class and had to set up a 7-segment display with only logic gates, input a binary number, and show the decimal number on the display. I did something very similar back when I was in college. Make it, oh, that would be cool. Yeah. So, yeah, Alka's mentioning Lab 424. That's a really cool Twitch channel. Is it just Lab 424 like that? Lab 424. Is it Laboratory 424? I just need to find the Twitch channel. But he does really cool things on his streams, and he has it set up so that you can do like commands in the chat to like shoot ping pong balls at him, and he built all the stuff himself. Laboratory 424. This thing. Yeah, Laboratory 424. That's the one. Definitely check him out. It's a fun stream. Conway's Game of Life with LEDs, that's actually not a bad idea. Though I think if we do something like that, I just might use JavaScript because I don't think I'm comfortable enough with C++, and it's a lot less code with JavaScript, but that would be really cool, actually. Yeah. Johnny 5 works with a lot of different hardware. Yeah. One can use SP8266 or node MCU that allows you to connect to Wi-Fi or send data to a web page. Yeah, so there's a thing called I think it's an Esperino? I spelled that wrong. Not Esperanto. Is it just SP? A low-cost Wi-Fi microchip with TCP IP stack and microcontroller capability. Okay, so this is like its own dedicated microcontroller. There is a piece of hardware. Thank you for the spelling. Esperino that is very similar to an Arduino, but it runs JavaScript natively. Esperino? Yeah, JavaScript for microcontrollers. So this is a special bit of hardware that actually runs JavaScript on the chip itself. So this thing's really cool too. Yeah, this stuff is fun to get into, and it's actually very approachable for people that normally just do like web development and software. And it's fun to like build physical things too. Yeah, it's a hardware stream. It's interesting. Yeah, we definitely need some terminology. All right, we got to get started. We've been streaming for about 20 minutes. Hello, Josh. Hello, everyone. Hello, Ryan. Things are good. Let's see if there's any more greetings. Hello, Mutasim. Hello, Rami. Anyone else, if you say hello, just make sure that your message says hello or hi in it. It'll pop up on this tab here. I'm gonna see if there's anything else interesting. Okay, my face was in that clip, so you can click that. Make it display your uptime so you can see it on your desk. That'd be cool. I don't think I have. We could do like hours, minutes, seconds. That could work. Hours, minutes, seconds on that thing. That would be fun. But for something like that, I probably would use Johnny 5 because it needs to contact an external API, and then it could just be plugged into my computer. But yeah, that would be fun. All right. The thing is, we're going to have to figure out how to hook this thing up. And I've never done it before, so we'll need to figure that out if we do it. Hello, Vicus. If you have a multimeter, you can easily measure the resistance or voltage. Cool. Yeah. Yeah, TMI and Johnny 5. And you can combine them together because they're just some node packages. The main issue, though, is the Arduino needs to be plugged into a computer that's actually running that program. What I'll show is the ones that we build with C++ are running directly on there. So we could technically unplug the USB and the program would still work. GameStep says, how did I get the drop in the chat? I don't know. I think sometimes people copy and paste it and it doesn't come through. But yeah, from basics to full robots in one stream. A 3x3 LED cube, yeah. We built a wall-following car using LPC4088 and the Bluetooth module. Oh, very cool. Yeah, so this past weekend when I was teaching the girls about robots, usually we do very basic programming. So we have a motor controller, which is this thing. And so this is known as an Arduino shield. It has these pins, and it plugs directly into the Arduino. And this makes it easier to program DC motors with this thing. So for the girls, we basically program this to control 2 DC motors, and we can control the speed and whether or not they're spinning of the left and the right motor. And then they just write basic programs to make it go around, and they pre-program it to do something. But one group of girls was very ambitious, and they got everything really quick, so they went above and beyond. So they connected an ultrasonic sensor to detect distance. They attached that on top of a servo that could rotate 180 degrees to see, like, it basically could look around. And then it would make decisions based on that. So it could go forward. If it sees a wall, it would then look with the ultrasonic sensor. What are these emotes? And then that would determine which way it should turn. And then it would turn till it doesn't see anything anymore, and then it would keep going. But yeah, they went above and beyond. And so I've taught that class 4 times now. And that was the first time I've seen any girls do that. So that was pretty fun. All right, this is a cool idea. Conway's Game of Life on LEDs. But yeah. What will be your one message to a person who is in high school? Start building stuff now. It's real, like, it's really easy to build things with hardware. It's really easy to build websites. And when you're young and you're in this mindset of learning, it makes it even easier, I would say. So just start building stuff. That's my advice to anyone in high school. Like, don't wait till you're in college. Don't wait for people to tell you. Just start building things. JavaScript is cooler. Okay. Maruf says, last day my undergraduate convocation was held, and it was really amazing for me. CJ, could you please share your convocation experience? I didn't like college at all. And is convocation like graduation? Yeah, I didn't like college. The act of convoking. But what does it mean? To call or come together. I think you mean graduation. I don't know. I didn't like college very much. It's long, it's drawn out. It's weird. I was just ready to get out of there. And my graduation ceremony was really long and boring. I don't know. I had a good weekend. Yeah, thanks Eternal Dev. Hello Dylan. Hello Hassan. JavaScript on a chip? Yeah. Yeah. All right. I think that's as caught up as I'm gonna get. Let's start building some stuff and learning. And hello Dylan. Hello Hassan. Hello other Dylan, I think. Hello Man on the Run from Greece. Welcome. And hello Katoli. Welcome. Yeah, Eternal Dev says, teaches you a lot of stuff you'll never use in the real world. Yeah, I think there are certain aspects of college, like learning to live on your own, having to do your own laundry, having to be responsible for yourself. Those are like lifelong lessons that I think are great. And I wish there were a better way to teach those lifelong lessons to people that are going out into the world, because things like trade schools where you're learning one specific thing that's actually applicable to the real world, that's the kind of thing that I think most people should spend their time doing, but I don't know. What color are the LEDs? Are they RGB addressable? No, so these are all just a single LED that has just like a colored shield on top of it. Yeah. Wings in the Sky. What did Wings in the Sky say? College equals scam, but not really, but kinda. It's like, it's a necessary evil is the thing. Oh. Let's look at this. This is the relation between volt, current, and resistance. Okay. No, that's the wrong thing. Okay. And this is a resistor, I guess. This is not a Raspberry Pi. This is an Arduino. We have a question that came in earlier. What's the difference? We'll talk about that, but first let's talk about Arduino. And hello, Cyanton. Welcome. And hello, Agent Key. All right. Even is this thing? So this is the Arduino. It is open source hardware. So and it's really good for prototyping, for basically building electronics projects that may not be like the final version, but it has these things here, which are digital inputs and outputs. I believe this is GPIO, general purpose input output. Also has them on this side, which allows you to control things with software. So what we can do is we can take a wire like this. We can plug it into one of these inputs or outputs, and then we take the other end of the wire and put it into a breadboard like that, and then we can plug electronics into the same thing here, and then we can, or like sensors and different things like that, and we can control them using software that's running on this chip here. And it makes it really, really easy. So, like I mentioned, this is open source hardware. So, the original version, they actually released the schematics, and anybody could go out there and build one if they wanted to. And that's why you'll find a lot of cheaper ones, like on Amazon. They're basically knockoffs, but they implement the same specification, and all of the code you write will work on them as well. And I think that's all I want to say about that. But they're really cool, and they're built for beginners to learn about hardware and programming. And on the Arduino website, they have this education section where you can learn all about Arduinos and hardware. And there is a reference. I want to go to the reference. How do I find the reference? Resources. Reference. There's also tutorials on here. But the main language for programming in Arduino is C++. So what I'll show here is the Arduino IDE, Integrated Development Environment, and this is where you can write your code. And so this uses C++, and there are actually a lot of built-in things. I believe there are some examples that we can just automatically include. I don't know. They're in there somewhere. But this is where you write your code, and it is C++, like I mentioned. There are other ways of programming the Arduino. We mentioned Johnny 5 earlier. Is it under file? File examples. Yeah, so there's a lot of different examples. So you have basics, blinking an LED, using your digital outs or your analog outs. So there are actually different kinds of outs on here. So over here are your digital outputs and inputs. And over here are your analog inputs. And so different types of sensors have different types of signals. So your sensor might need to be an analog in. Is it more beginner friendly for Raspberry Pi or Arduino? I think that's what you're asking. It varies. I think the cool thing about a Raspberry Pi, like I said, is it has built-in Wi-Fi. It has built-in, and let's do this really quick. Yeah, PWM is pulse width modulation. Yeah, do we see that on the chip there? But yeah, so these digital PWMs, and so there are certain things that require pulse width modulation to control. So we would use those. Have I heard of Onion? This isn't the Tor network, is it? Oh, it's a computing platform. IoT compute platform. Cool. And so while this is kind of relevant. So you might have seen this term thrown around on the web, IoT. This is called the Internet of Things. It was like a serious buzzword a couple of years ago. I think it's somewhat died down now. But the idea that most things will be connected to the internet. So you have smart fridges and smart vacuums and just all kinds of smart things that are connected to the internet. And something like an Arduino or a Raspberry Pi is a really easy way to build your own. Yeah, so servos use pulse width modulation. Yeah. Cool. So real quick, because it was mentioned, let's talk about the difference between an Arduino and a Raspberry Pi. So an Arduino is a microcontroller. So this chip right here can only do one thing that you program it to do. And right now, I have this program. And in the setup function, I begin the serial communication with this rate, and then I just print hello world. And then over here, I can actually see the output that's running on the Arduino. So if I upload this to the Arduino, it'll set up and then run, and we should see hello world printed. Cool. But the thing is, this one program that I wrote right here, that is all that lives on the memory and will run on this microcontroller. It can only do one thing. You basically write one program, and this microcontroller chip will run that one program. What's different about a Raspberry Pi is the fact that it's a full-fledged computer. So it has an operating system. You can run multiple programs at the same time. You can write things in Python or C++ or JavaScript, all running directly on the Raspberry Pi. So that's where they're different. They can do similar things because a Raspberry Pi has general purpose inputs outputs like this, but you can control those general purpose input outputs with all kinds of different libraries and many different languages. So that's the main difference. Raspberry Pi is full-fledged computer, has built-in Wi-Fi, built-in Bluetooth, at least the latest versions. And you can control things similar to Arduino, but you can use many different languages because it's a full-fledged computer. This is a microcontroller. It can only do one thing, whatever you program it to do. And if you want to do things like access Wi-Fi or access Bluetooth, you have to get a separate shield for that. So I showed this earlier. This is a motor controller shield. You'll find things like this that will plug basically directly into the Arduino, and it makes it easier to do certain things. So this is for controlling DC motors, but you can find shields that give Wi-Fi access or Bluetooth access to your Arduino. Yeah, and so it's not running an operating system. It's embedded, meaning that it's very low level. It's just running one thing at a time. That's the main difference. Yeah, and so and when 32Day mentioned Arduino Uno, this is an Arduino Uno. There's actually a lot of different Arduino versions. Let's see if I can find them on the Arduino website. Bye. Yeah, so there's the Arduino Mega. There's like these like very small Arduinos. There's the Arduino Micro, but then these are also like Arduino chips that have like Wi-Fi built in potentially. I don't know all the stuff that I'm looking at, but there are different boards and modules. Let's look at these. So the Uno, can I just see boards? I guess not. Yeah, and then the Arduino Mega has 250 kilobytes of memory. So this thing only has 32 kilobytes of flash RAM, whereas an Arduino has like gigabytes, I believe. Let's look at like Raspberry Pi specs. If you get the Raspberry Pi 4, It has like a over 1 gigahertz processor. Yeah, and so this is a Raspberry Pi. It has HDMI out. I believe these are like micro HDMI. Though this is not a 4, is it? Maybe it is. It has USB inputs. There's a Broadcom chip on here that supports Wi-Fi and Bluetooth. And then these are the GPIO, the general purpose input output. And it has Ethernet. So Raspberry Pi has a lot. So let's see. The Raspberry Pi has a quad-core 1.5 gigahertz processor. That's this thing, I believe. What else? It has a Broadcom GPU. It has Bluetooth, Bluetooth Low Energy, and it has either 1, 2, or 4 gigabytes of RAM. So, and there actually isn't any onboard memory. To actually put an operating system on it, you need like a micro SD card. But yeah, that's the major difference between these. Yeah, and thanks for the follow, Dabus. They just came out with dedicated boards for Nanos that are different, that are better for different areas of IoT. That's good. Yeah, so I'm thinking like built-in Bluetooth, built-in Bluetooth or built-in Wi-Fi, that kind of thing. That thing is what? I haven't really used MQTT before, but we could look at it. Maybe not today. Yeah, and then the BeagleBone is similar, but I believe a bit more powerful than the Raspberry Pi. Or the BeagleBoard? BeagleBone? I've seen other single board computers like this that have insane specs. So that might have like an 8-core CPU and like gigs and gigs of RAM all on this tiny little board. And these are much more powerful than Arduinos. Don't worry, it's hard to fill 32Ks of memory using C. You'd be surprised. I don't have any servos. I gave them all away to the girls last weekend. But I might get some more, but I don't have any with me. Raspberry Pi isn't really an embedded system, says Kelly. It's a general purpose computer when running Raspbian. Yeah, so this is an embedded system. Raspberry Pis can run a lot of different distributions of Linux. Is it all about price? No, I think it's about just doing different things. And both like the Arduino, I don't know if it's the Arduino Foundation, but there is the Raspberry Pi Foundation. They have different, maybe not different, but similar motives in mind. The idea of getting young people interested in electronics and programming early on. And with Raspberry Pi, that was about getting like a full-fledged computer in the hands of people, like anyone, because that computer costs itself $35 and it has HDMI out and you can plug a keyboard into it. You can also program it and learn about stuff like that. But that was more about getting any computer in the hands of anyone that could afford a lower amount of money. The other thing is there's things like this, which is a Raspberry Pi Zero. So you can look at this. This is like a mini, like you can see it's even smaller than the Arduino. But this has HDMI out. It has USB out. You need adapters for it. It has lots of memory. It has Wi-Fi built in. But this is just an even smaller Raspberry Pi. Yeah. So that's the thing. All right, so that's enough for like the basics of all this stuff. Okay, Dylan is asking, so why wouldn't you just get a Raspberry Pi? I'm sorry, I'm just not clicking since Raspberry Pi seems like the better option. The main thing is like, it depends on what you want to do. And all of these different websites, like the Arduino website, the Raspberry Pi website, all of their learning resource sections have things like tutorials that will basically walk you through different things that you want to do. So let's look at the tutorials here. So they have built based on examples. Let's look at the built-in examples, which are these here. Reading from different things. So it's hard to say. Like Arduino is a lot lower level, and here's the thing. So any piece of electronics that you have has like an electronics board inside of it that does something. So what I'm thinking about right now is I have this, you can't really see it, but I have this USB hub over here. And that itself has a little microcontroller on it that allows multiple USBs to be plugged into a USB port. Now, you could actually prototype that with an Arduino. So you could basically buy USB inputs that aren't soldered, and you can plug them in, and you could use something like a breadboard to hook it all up, and you could write C++ software that would control that USB hub. And this is just your prototype. Then you could take the circuits that you created in terms of like what wires connect to what and what resistors you need, and you could actually build a custom printed PCB board that has all of that built into it, and put a chip on it that isn't the Arduino. So I think that's the major difference. Like Arduino is for prototyping embedded hardware, whereas Raspberry Pi is like more than that, and you can prototype things and you can plug things into it, but for the most part it's kind of like a full-fledged computer. But as a beginner, both are good options. I don't know, hopefully that helps a little bit. and that's the other thing, Raspberry Pi is really cool for and really good for getting started with Linux. So you can learn about setting up Linux from scratch and installing things and learning about the terminal all on a Raspberry Pi, where as an Arduino, you don't do that. Let's see real quick. The Jetson Nano. Is this a thing, Ronnie? Ooh, that's pretty cool, Deep Sense. Hello, DepoPam. we're gonna program the Arduino. Arduino start operating running your code within several milliseconds from power on. Raspberry Pi takes several minutes to boot. That's another point. So a Raspberry Pi literally has to boot up the operating system before it starts running. This thing doesn't have an operating system. It's much closer to the metal. Your program will just start running the moment this thing boots up, for the most part. Yeah, that's a good point. With a Raspberry Pi, you have to get started with Linux. Arduino, you just start coding and plugging things in. And thanks for the follow, Bloot. Yeah. And hello, B-Man. Win320day says, we use Arduino just as a prototyping tool. Afterwards, we design our own PCB with the Atmel chip on it. Yeah, so I guess this is the Atmel chip. And you can just buy these individually. And yeah, it's interesting once all of this clicks for you, because the idea of like plugging a wire from here to here, if you've ever looked at like a circuit board, that's actually what it's doing. You see these lines running and these solder points. They basically took a prototype like this and condensed it and turned it into like really small connections and stuff like that. Okay, so this is the Arduino. I want to show you the basics of a breadboard here. So what we're looking at is a breadboard. I'm going to take this wire out and let's talk about it. So breadboards work differently. Most of them work this way though. So we can see there's this blue line here. And let me zoom in on this thing here. Hello, B-Man. My tips are to just buy an Arduino and get like a basic electronics kit. I'll try to link to some later if you remind me, but there's like this thing you can get on Amazon. It's called the Upgraded Electronics Kit. This thing comes with a breadboard, wires you can use. I believe it comes with, wait, this might not be it. I have another one. You can get, but the kit itself costs like $10. It has everything you need to just start playing around, and it comes with a breadboard like this. But okay, so this is a breadboard. What is that? Oh, I think that's the USB cable. And this blue line here, and all along here, so everything that's in this same, let's call it a row, is connected together. So if you look on the Arduino, there's a section down here called power, and there is a place you can plug in a pin that says ground. See the G and D there? I have a somewhat of a pointer device. So right there, you see that it says ground. This is the ground output. So what we can do is we can take a wire, plug it into that one that says ground. We're gonna go right there, and then we take the other end of the wire and we'll plug it anywhere that along this this blue horizontal row. So I'll plug that there. Now that I've done that, this entire horizontal row here is connected to ground. So if any of my circuits call for connecting to ground, I can just run a wire from anywhere on this blue line to wherever it needs to go to, and that's now connected to ground. Cool. The next thing is power. So if you look on the Arduino board, there's a pin that says 5V. It's kind of hard to see from this angle, but there's one that says 3.3V and 5V. So 5V is 5 volts. So if we connect a wire from the 5V, which is going to be this one, then we'll plug that one into the positive, which is the red line here. And so now that I've plugged that in to the red, this entire red row here is connected to power, and this entire blue one is connected to ground. So this is kind of like the base of my circuit. I have one entire row of ground that I can use and one entire row of power that I can use. Now let's try to light up an LED. And what we're going to do is we're just going to make it so that the LED is always powered on. So we're going to connect it to the 5-volt power source so that the LED is always running. Let's see. Oh, thank you, Alka. That's a good image. So like I was showing, all of these blues are connected together. All of these reds are connected together. And then I haven't shown you the internals yet, but basically every single one of these rows is connected together. And this helps you with building circuits. So what we are going to do is we're going to light up this LED. We have this blue LED here. And if you look at any LED that's like this, you'll see that it has 2 ends. One end is longer than the other. I don't know if you can see that very well, but in this case, the left side is longer than the other one. So the left side is what we need to connect to the power. And then the right side is what we need to connect to ground. So here's what I'm going to do. I'm going to take this LED and plug it in just right here. So like Alka is showing in this diagram, because each one of these rows are connected, basically I'm plugging the positive, let's say, into row 30. So positive is now in row 30, and everything along this row is connected together in 30. So that's there. And then I have the negative end plugged into, let's say, 32. And so everything there is connected. I would never put them together like this, because now I've just connected positive and negative. I've connected ground and power. You don't want to do that. So you need one to be one place and one to be the other place. Great. First thing we'll do is we'll hook up the ground. So I'm going to take one wire. You can plug it anywhere on the blue, because that's our ground, remember? And then I'll take this end and plug it into the same row as the ground on our LED. Great. So we've now grounded our LED. Now we need to provide power. And the thing is, we can't just plug it in, because 5 volts of power is actually way too much for this LED. But you know what? I'm going to do it anyway so you can see what happens. And before I do that, let's catch up. Oh, cool. Yeah, hopefully this helps Depopam. 1 a.m. Hopefully you get some sleep too. Yeah, I'm blocking that diagram. Oh, was I? Oh, sorry. Here. So all the reds are connected, like I showed. All the reds. All the blues are connected, and then each individual row is connected. Cool, that's a good diagram. We can't see it. Yeah, I couldn't see your messages. Sorry. Yeah, the LED needs a resistor. I'm going to plug it in without a resistor just to show you what happens. And the thing is, I have plenty. I have plenty of LEDs, so we're going to bust this one and we'll use a new one. I'm sorry. Current limiting the resistor. Not yet. Not yet. That poor LED. It's not the voltage, it's the amperage that kills it. Okay, that's good to know. I'm not totally and completely familiar with all this stuff, but it just goes to show you don't really need to know much to even get this stuff working. And of course, if you want to know, you can learn it. Okay, so we need another wire. I'm gonna take this one, and actually, what I did here, this doesn't make a lot of sense. So I plugged the red wire to connect to the ground. Technically, wire color doesn't matter, but you should be consistent, because I should probably use this red wire to connect from my, oh, and I plugged the power into the ground accidentally. That was the wrong thing. Oh, no, I didn't. Yeah, I did the wrong thing. Let's work on our wire color. So, because this is orange, we're gonna plug this into power, and typically a red or an orange cable is plugged into to power. So we're gonna use the orange one, and then that one goes to the power there. Cool. And then the green one, green is commonly a color used with ground or brown or even black. Wire etiquette, yeah. And we'll plug this one into ground, and the other end into the ground over here. So, like I mentioned, wire color doesn't actually matter. We're just literally connecting one thing to another, but it is good to be consistent. Rip that LED. No, I'm not left-handed. This is my right hand. Yeah. I love how you blow up that LED and don't really care. Yeah, they're cheap. It's easy. Ohm's law. Okay, so now that we've got our wire colors good, let's actually grab either a green or a brown wire to connect to the ground. Here's a nice green wire. Cool. So now we can go from the ground, remember anywhere on that row is ground, to this row, because that's ground. Awesome. All right. Drum roll, please. Weird. I just flicked the light switch on. So what we're about to do is I'm gonna take one wire, this red one here, and I'm gonna plug it into the red. So now this isn't plugged into anything, but it has power. It has 5 volts of power going through it, and I'm gonna plug it into the positive end of the LED. It'll light up for a second and then just pop. Yeah, drum roll. Here we go. I put it in the wrong row. Okay, here we go. Oh. Well, that's weird. It didn't pop. It can literally take 5 volts of power. That's crazy. Why didn't I not need a resistor? Weird. Maybe this is just a really good LED. Let's find a smaller LED so we can pop it. It will die eventually. Okay. Yeah, actually, it's getting less and less bright. Yeah, this is like a lot smaller one. I want to show this. I will smell it soon. I'm gonna unplug it, and it's not that hot, so I'm gonna unplug it. We're gonna use this one, which is a little bit smaller. You can see the two compared. So there's that green one. There's that. Well, no, they're the exact same size. Oh well. Basically, what people are saying is the amperage eventually kills it because it's just way too much power. So what we need to resist the current that's going to it. So I'm gonna plug this one back in. The smaller end goes to ground, and then I'll plug this one into the positive. Oh yeah, it died. It was an instant death. So now I've basically broken this LED. We can throw this one in the trash because we put too much power to it. So what we need to do is resist the current that's flowing to that LED. Let's find another one. A blue LED has a higher current ratio than green LED. That's good to know. So that's why the green one burnt out instantly and the blue one didn't. So we're going to use this new green one. It's a freshie. We'll connect this in to ground. And now we need a resistor. This is a 10K resistor. Does anyone that's in the chat know like how I can figure out the best resistor to use for this LED? Now, these LEDs don't come labeled. Okay, so the forwarded voltage of a green LED has 0.7 and blue 1.7. Okay. And so I'm pretty sure this 10K resistor will work because I see that well, actually, maybe not. I have some missing from this. Oh, nice. Alka clipped it. So you can see it here. It happens instantly. Like the moment we give it 5 volts of power, it like bursts. That's great. Thank you, Alka. That's really good. And this is 330 ohm resistor. Okay, we can Google it. Ultimately, also what I want to show is how we can calculate the resistance of these. So basically, that's where these come into play, right? When I plug this directly in, that's 5 volts of power, right to the thing, and that bursts it. But if we reduce the amount of volts going to that LED, it will stay on and it won't burn out. And so that's what a resistor is going to do. It's going to resist the current flowing to that LED. So Kelly Murphy is saying a 1K resistor should work. Let's find one. So the thing is, some of my resistors are labeled. Like this is 5K1. This is 100K. This is just 10. Doesn't say K on it. V equals IR, Ohm's law. I guess that would allow us to calculate the resistance that we need. There we go. And so, yeah, so we can calculate the resistance of the thing. I'm just trying to figure out what resistance do we need. Okay, Dabu says use Ohm's law to calculate the needed resistance. So if we go by what Win320day is saying, and that a green LED has a forward voltage of 0.7 volts, 0.7 equals I times R. What is I? Brown, black, and red are the colors I'm looking for. Yeah, and so that's the other thing about resistors. It varies. So these are 5-band resistors, and so I'll try to show this. You can see that on the resistor it has several different bands on it, and you can basically calculate the amount of resistance on this thing based on the color of the bands. And so Win320day is saying a 220 ohm resistor should be enough. Oh, look at that. So this is an entire set of 220 ohm resistors. And I think the reason they gave me so many of these is the fact that this came with a kit with a bunch of LEDs. So we're gonna go with that. we're gonna use this 220. But I will show really quick. Let's just find like an online resistance calculator, because I have some resistors here that aren't ledcalc.com. Let's go there. Oh, this will calculate 2 easy steps. Enter the argument. So the supply voltage is 5 volts. The voltage drop across the LED is 0.7. Was that what we thought? The desired LED current, 1. Number of 21? 21 milliamp? I don't know how to use this. Okay. As LED forward voltages, 2 volts. Oh, I put 5V. Sorry. I did. I don't really know how to use this. But what I do want to show is a resistance calculator. Ohm's law calculator. Oh, there's that. Say resistor calculator. 4-band resistor calculator. We're gonna go to Google. These are not things. Find your resistor. So here we go. We choose the number of bands. Let's just go with. We'll go with this. Like, we know this is 220 because it's labeled, but let's go with what we see. 3, 4, 5. Yeah. So the number of bands on this thing. Let's make this a little bit bigger. Number of bands is 4. And hello, Ed. Welcome. Number of bands, 4. It's a little hard to see. But the first band is, put this over here. Brown. So we're going to go with brown. The second band is black. The next one is, I want to say that it's black. It might actually be like a dark green. I'm gonna go with black. Oh no, this is a 5-band resistor. Okay. First band, brown. Second band, black. Third band, black. Fourth band, brown. Tolerance, brown. I think I did it in reverse. Let's go the other direction. So we say brown, brown, black, black, brown. We get 110 ohms. Well, it says 220. It's labeled as 220. This might be dark green. I'm going to go with dark green. I'm going to say this second to last one is dark green. I guess it's 115. Is it blue? I can't really tell. Well. Oh, is this last one red? I don't know. This is so hard to tell. And then let's call this black. That's 110. Let us see. I don't have a what you call it? An ohm meter. Here, I can adjust the zoom on this thing. Advanced. Or I try adjust the, oh, you can't see it. We're gonna put this here. I can adjust the focus. Oh, did this thing break? This broke. Well, that's unfortunate. I need to restart my webcam thingy. Red, red, black equals 220 ohms. Okay, cool. So there's that. We're gonna try to get this thing into focus. No opacity. Advanced webcam control. Here we go. Where'd it go? Oh, man. Oh, that's pretty good, actually. That's way better. So it's definitely brown, black, black, red, brown. Look at that. Look at my fingernails, too. So, brown, black, black. Wait. Brown, black, black, red, red? Red, brown? Let me know in the chat. I'm going to leave this here for a second. What do you think this is? Oh, thanks for the picture, Alka. Red, red? Let's try it. Use a color picker. I also need to... Oh! Also, how do I look at this? Do I look at it like this, or do I look at it like this? From left to right. Brown, black, black, red, red. Okay, we're going to go with that. Let's put that there. Brown, black, black, red, red. That's 10K. Let's go in the opposite direction. So what if we say red, red, black, black, brown. 220 ohms. That's the winner. Okay, so what we actually need to look at it in the opposite orientation. Flip your image, Alka. So it's actually red, red, black, black, brown. Yeah. There's marking on the resistor wire showing which side to read from. I don't know if I see that. Yeah, I don't know if I see that. For 220, red, red. Okay. Red, magenta, black, black. Let's try red, magenta. Which one's magenta? Thank you, Aka. So it's red, red, black, black, brown. All right, we'll go with that. And it matches up with what was written on here, so we'll go with that. You can usually figure it out. Now, let's actually use it. So, the right side has that gap after the third. Yes, that's true. So in this little dilly, yeah, okay. That makes sense. But what confused me is that this brown is actually on this thing here instead of being inside of it. But it does look like there's a larger gap between this one and that one. So that would let us assume that this is the direction that we read it in. Okay, good to know. All right, let's get this LED lit up. So, given that we've figured out the amount of resistance, which is 220 ohms, we are now going to do as follows. So on our little circuit here, we're gonna take this resistor. It doesn't matter which way you plug it in; it's gonna work in both ways. And we need to connect one end to 5 volts. We need to connect one end to the actual power. So here's what I'm gonna do. I'm gonna take this wire that I had, this free wire that I burnt the LED with earlier. We take that one out, and then I can take this resistor and just plug it into the power, the 5 volts, and then plug that directly into the same row as the LED. Like that. So now the LED lights up, and actually it looks very bright on camera. In person, it's not that bright. It's way less bright than that blue one was earlier. But what we did was we took the one end of the resistor and plugged it into the 5 volts here. And then we took the other end and plugged it into the positive of the LED. You can see that here. And so that does it. So now instead of being plugged directly into 5 volts, it's being resisted by 220 ohms, which results in how many volts? I don't know. I think we can use this calculator to figure that out. Let's put this over here. Even I did this in high school, and it's so fun to watch. Yeah. Hans says, I forgot about absolutely everything. Yeah, and so this is really just the basics. As you can see, I kind of don't know what I'm doing, and I'm still able to fill it out, to make it work. And Win32 is saying most LEDs draw 21 milliamps. So let's just put that number there. 5 divided by 220 is 22 milliamps. I see. So by doing this, we're now sending 22 milliamps instead of 5 volts to the LED. If I mouse over the question marks, it gives me examples. Oh, okay. Amount of the current that the LED uses when powered up properly. Okay, so let's say 21. Amount of voltage that the LED requires to light up properly. So here, we actually need to do 2.2. And then the supply voltage is because we connected it here. And actually, so one thing to mention is, well, let me put this over here. So the reason, or not the reason, the way that this Arduino is actually getting power is because it's plugged in via USB to my computer right now. So my computer is actually supplying the 5 volts to the board, and then this pin here, the 5 volt pin, allows us to take that 5 volts and put it into the breadboard. So that's where the power is coming from USB. What you can do is actually plug in a battery pack to the Arduino, so you don't need to be plugged into a computer, but that's where we're getting our power from. This might be interesting. Let's look at it. Make it dim using the PWM port. Okay, we could do that. What I want to do first is just turn it on and off, because you may notice right now, you can't really, it's hard to see because it's so bright, but right now it's always on. Like, we haven't written any code for this. We're literally just providing it power, and so the LED is always on. But what we can do is, instead of plugging into the 5 volt on the Arduino here, we can plug into one of the digital outputs over here. And the digital outputs we can control with software. So we can write C++ code that says, send the power, don't send the power, send the power, don't send the power. And that will actually allow us to blink it with code. Rather than right now, we can't control this because it's directly plugged into 5 volts. It's always going to be on. Well, not directly. There's a resistor in between. So this is super cool. This is a website where you can actually... let's see, I guess I'll log in with Google. That one. You can build your circuits, and it'll show you what will happen. Skip. Continue. Jeez, come on. Hello, Linus Dev. Welcome. Yeah, we're going to definitely flash that LED. Wait. Well, this is like a CAD software. How do I get the... All right, now that I'm logged in, maybe I can go here to learn about circuits. Tinkercad circuits. Oh, I selected design instead of circuit. Okay, I didn't mean to. All right, we're gonna start off with a breadboard. Can I click it? Oh, look at that. And then I got an Arduino Uno. Look at that. We're gonna digitally build this circuit. Now I need a wire. Can I just click it? Yeah, so I'm going to go from the 5 volts to the power, like that. And I'm going to go from the ground to the ground, like that. Then we need a resistor. We're going to do... I mean, actually, I guess if I do this, we can connect that end to the power, like that. Color... green. Can we set the amount of resistance? Yeah, here. So the resistance, we're going to do 220 ohms. Ohms? And then we can take an LED. And so this is the positive end. We need to plug the positive end. Actually, I wonder if I can flip it. Guess I can't flip it. But this is the positive end. We're going to connect that to the resistor. And then this is the negative end. We're going to connect that to ground. And then how I can plug it in? Plug it in. I can write code in there too. I do have a oh yeah, we could do that too. So first thing, okay, this is the plan. We're gonna write code that blinks the LED. Then we'll attach a button, and we'll write code that only turns on the LED if the button is pressed. Start simulation. Hey, it's lit up. So this is really cool. So for those of you that want to get started with Arduinos and stuff like that, you can just do it digitally. You don't have to worry about frying an LED or anything like that. Is the anode the short one and the longer one is the cathode? I think that's a good. I think that's what it's called. Yeah. So anode is the ground or the negative end, and cathode is the positive end. That sounds right. There are some electronics people watching. They can confirm that. Cool. All right. So that was fun. But yeah, let's blink this thing with code. So if we look at the Arduino reference, Depopam says yes. Like you said, cool. That's good to know. What we want to do is a digital read. So we're going to read from one of these digital outs, and if it says we should have the LED on, then the LED will turn on. So we're going to do digital read. And we'll also do pin mode. So let's do this. We're going to unplug from our 5 volts. Let me make sure you can see this. So right here, right now, this is plugged directly into 5 volts. I'm actually going to unplug that. And I'm going to update my circuit here. So instead of plugging this into the the power end, I'm going to plug this into just another row over here. So that goes there. That goes there. And then I'm going to take this wire and plug it into the same row as the resistor. Cool. So now if you look at my circuit, the resistor goes from that red wire or that orange wire to the cathode of the LED, the positive end of the LED. And now we're going to take this end, and instead of this being plugged into 5 volts, we're actually going to plug this into one of the outputs. I'm just going to choose number 13. 12? Interesting. When I do 13, that light goes off. Maybe that's not actually 13. Let's see. 8, 9, 10, 11, 12, 13. Okay, this one is 13. All right, we're going to go to 12, though. We're going to go to pin 12. So because I plugged it into 12... Oh, 13 is for the onboard LED. I see. That's good to know. So that's why that happened. When I plugged that in, we actually... I guess we sent it through the resistor? Weird. But yeah, we're going to use pin 12 because we don't want to adjust the onboard LED. Okay, so we have this plugged into pin 12. Now we can write our codes. So, here we go. They typically store these things in variables just so they're reusable. But what we need to do is first call pin mode. So let's go to our Arduino program. We printed hello world, that's great. Oh, and here's the other thing to mention about the Arduino program. Setup will always run once, and then loop gets called over and over and over and over and over and over again. If you've ever used P5.js, it's kind of a similar idea where you have this function which runs once, and this one that just runs over and over again. So the loop is great because you can do things like when the button is pressed, do something, and you're constantly checking, is the button pressed, that kind of thing. But for now, let's set up our output mode. So we plug this into pin number 12. You can see it's plugged into pin 12 right there. So in our code, we're going to say pin mode 12 is output, like that. And we can actually put this in a variable. So since we're in C++, we have to type our variables. So I'm going to say LED pin and set that to 12, and then we can use this variable right here, LED pin. And so now we've told the Arduino that pin 12 is going to be used for output. We're going to be sending a signal to the LED to turn it on, so that's great. And then next up, we can use digital write. So here, what are they doing in this example? What are they reading from? Oh, I thought I would. I guess they were. In this example, they're reading from something else, which will turn the LED on and off. In our case, we're just going to turn the LED on. Win320day is saying it's handy to use a char instead of an int because the pins only go to 13. Oh, so what character is equal to 7? Uses less memory? That's good to know. Oh, and I didn't mention this earlier, but Coding Room is saying you can use the LED built into the Arduino for this example. Because what was mentioned is this little light here is actually connected to pin 13. We could control it. We're going to use our external one, though, because that's going to be fun. Yeah. Okay, and now we just write it. So, and really, right now, I just want the thing to light up. So I'm going to put it in the setup. It doesn't really need to be in the loop. I'm going to say digital write to that LED pin. And we want this to be high. High means to turn it on. Low means to turn it off. So if I've done everything correctly, first thing you can do inside of the Arduino IDE is click the check mark, which actually compiles your code, and make sure you don't have any syntax errors. So if that works, then we can upload it to the board. And if this is successful, the moment it uploads, that LED should turn on because we're now setting digital write to high on that pin 12. Here we go. There we go. So the LED is on, and it will always be on because we never turn it off. So that's great. Great. Now let's make it blink. So here's what we're gonna do. We can create some variables like a boolean. So I can say like bool is on, and initially we're gonna set that to true, like that. Now, instead of digital write in our setup, we're gonna do it in our loop because this loop is gonna run over and over and over again. Put this here. Hello, Sujan. So we can say if is on, then digital write LED pin high. Great. Else we'll do the opposite. So write it as low, which means to turn it off. All right. So now we need to flip is on back and forth. So what we'll do is right here we'll say is on equals not is on. Right? So that's just going to take the boolean, and if it was true, it sets it to false, and if it was false, it sets it to true. Great. Now, I'm going to upload this program, but you're probably not going to see a difference because this loop is running very, very fast, over and over again. So you'll probably never see the LED turn off, or you'll never see it turn on. But here we go. Let's see what happens. Upload. Yeah, so it just looks like it's on all the time. We could probably figure out the frame rate. It might have to do with the fact that I've set up the baud rate of serial, but there's this handy function built in called delay. So we can just do that here. So let's say delay 1 second. I think this is in milliseconds. So now this should blink on and off every 1 second. So instead of constantly looping, before the next loop runs, it's going to wait 1 second. So now we should see a blink. On, off, on, off, on, off. Very good. We did it. And Dabos is mentioning you can also use C. Yeah, so this is C++. And these functions that we're using, like pin mode, serial, delay, all of these are built into like the Arduino libraries. So behind the scenes, when it's compiling, someone else wrote this low-level code for what happens when we do digital write and delay. And technically, you could see as well. So you would need another. Yeah, we're pros. We can blink LEDs. So it's blinking slightly slower than once a second. I would say so because like this always isn't going to be like perfect. And then it comes back around in the loop to turn it back on. So yeah. Yeah, so Kelly is saying the frame rate is equal to the system clock divided by the number of clock cycles per iteration of the loop. Using the serial out, we can actually print every time a loop runs without the delay. But yeah, so Tramstar has asked about how do you control what language to use? You would probably need another IDE. I don't know if this IDE supports compiling C. But this one, by default, only supports C++. There are ways of writing like other languages that will compile for the Arduino, but you would just need to use some other set of tools. So for C, I'm sure there's some IDE that supports that. But it's pretty great, right? We're blinking an LED. Let's get the whole circuit in frame. There we go. And just a quick review. So we have one wire going from ground to our ground here. We have another wire going from ground to the anode of the LED, which is the ground of the LED. We have a resistor connected to the cathode, which is the positive of the LED, plugged into this orange wire here, and then this orange wire is plugged into pin number 12. Make it fade in and out. We could. I've never done that before, but what was mentioned is we could use the digital PWM. Let me focus this. This is a little out of focus. Did this just freeze? Come on. Oh, that's much nicer. But out here is the digital out PWM, and so this will actually control. We could control the brightness of the LED. Yeah. Um, do we want to do that? Because instead of turning on and off, we could actually fade it. Do manual PWM by setting the pin on and off. That could work, yeah, because pulse width modulation means it's like moving. We technically, I believe, could use these pins as PWMs if we wanted to. I don't think I'm gonna do that because I wanna wire up one of these things here, and that's gonna take a while. I've already been streaming for 1 hour and 15. I'll use a potentiometer. Hello, Andrew. Welcome. But this might actually be fun to do with JavaScript. So we could use Johnny 5, contact the Twitch API to see our uptime, and then show our uptime on this LED. So we could do like hours, minutes, seconds, or something like that in terms of uptime. I think that would be cool because we could we would be using Johnny 5. So everything I've showed you so far would mean nothing because this is all C++. And I can't really demonstrate it right now, but this program that we wrote is running directly on the Arduino. If we were to use something like Johnny 5, it doesn't run directly on the Arduino. It has serial communication between like a JavaScript program that can control it. Count the number of... I could do that too. So because it's JavaScript, I could tap into my backend message API, and every time a drop happens... Well, I mean, we could do that too. We can make every time a drop happens, flash the LED or something like that. Or the follower count. Yeah, I think this would be cool for Twitch follower count. Yeah, we still have YouTube messages, but YouTube doesn't give you a low level subscription thing. Plug the USB cable into a cell phone charger and it'll still run to show it. That's a good point. I actually have a battery pack I could probably use. Let me do that just to demonstrate. What I'll show is right now this USB is plugged into my computer. So the power is coming from my computer. But I could take that USB and put it into a battery pack, and this LED would keep blinking because the program is running on there. Okay, I think I wanna do something with this. I think that makes sense. Well, let's put it to a poll though. The only issue with this one, which is an 8x8 LED grid, is I think I would have to use this chip to program it, and we'd have to look it up. We'd have to look up the specifications for this chip. We'd have to plug this chip into this thing. That could get a little bit more complex, but I think we're going to put it to a poll. And I think at this point, I've decided I am going to use JavaScript. Okay, so that's the basics of the Arduino. Hopefully you learned a little bit, and hopefully I've inspired you to go buy one and try this stuff out. This chip is the 1838H HXL E4. So 1838 HXL E4. And I believe that's used to control this 8x8. I think you can control it without it. It just requires a lot more wires and other things. Yeah. But also, before we move on to JavaScript, I want to get a button working. Just to show that when a button is pressed, we can light the LED if the button is pressed. Oh, cool. Yeah. That's awesome, Polar Fluke. So I have this little button here, and I'll show you really quick. It's detached. So I have the plastic piece and then the actual push button right there. Making a dyno for cars. Calculate the horsepower with Java and make a graph. Interesting. Yeah. These are all just one color. I believe they're reddish. We could test it. I think. I don't know if we can test it. We can try to test it. I might bust it, but I think we can plug this in and then take a wire coming from 5 volts that is connected to a resistor and then try each individual one and see if it lights up. But I think it's red. But let's just do this really quick. Let's hook up this button. So what we can do is when the button is pressed, light the LED, turn it off when it's not pressed. So we're going to set that up. I think that sounds like a fun little challenge. And then we'll move on to fancier things. Test it, bust it. So Let me just see really quick. There we go. And you will notice that I plugged this button in across the divide here. So I mentioned earlier that each row is connected like that, but except across this divide. So they're not connected here. So I have two potential connection points here and two over on this side. Oh, cool. So Win32 is saying we can go here for the LED matrix. With that grid, you can show the value of 8 bytes or an entire single integer. That'd be a pretty cool visualization. You mean like each one of these LEDs represents a bit, and then it lights up based on the bit in that number? That'd be pretty cool, actually. Ooh, yeah. You can do cool things with it, though. You can like draw a heart, draw a smiley face. So you need wires. You need this. What else do you need? Okay, so we're defining our rows and our columns. Where's the circuit? Show me the circuit. Schematics. Oh, you don't even need a controller. You literally just can connect every single part to it. This might be fun. All right. Display the time in binary. That'd be fun too, like a binary clock. Trimstore, no, I'm not just getting started. So I teach like the basics, just like I showed you, to high school girls in a program called Chick Tech. So I've been messing around with Arduinos for a long time. And I've messed around with Raspberry Pis for a long time too. I haven't done any like super complex projects, but I know the basics. And when I was getting my computer science degree, I did learn about breadboards and stuff like that. Yeah, so that's one thing I didn't mention. There's a button right here, but this is the reset button. And whenever you press this, the program will stop and it will reset the Arduino. So the program will start over again. So this is useful for doing that. Beasting the Arduino. That would be fun too. We can make Pong that goes back and forth. We could potentially make it controlled by chat. So like you could send a message that lights up one specific LED on here, and then you all could collaborate to make images on it. I think that would be a fun project. That would be pretty cool. But here's what we're gonna do. Mini DVD bounce, yeah. But here's what we're gonna do. I'm gonna get this button working just to show how buttons work, and then we're gonna switch over to Johnny 5. Because that's gonna make it a lot easier to write the code for it, and do things with like a board like this, which requires quite a bit of programming. So we're gonna do a poll. Though actually, I just like that idea. I kind of want to do that. I want to make it so that Twitch chat, or either YouTube or Twitch chat, can turn on any one of these LEDs, and then you all can like collaborate to make an image on there. But see you later, Linus Dev. Thanks for hanging out. I think that's what we're gonna do. That's the plan. I'm gonna take a quick break though. So I'm gonna take a 7-minute break. When I come back, I'm going to have a battery pack with me. So I'll show you that this Arduino will keep running this blinking program even when it's not plugged into a computer. We will get this button to turn the LED on and off. Yeah, and this is really cool. I've seen videos of people soldering these things. It's basically like a matrix of LEDs. Yeah. That's exactly what happens, Doc, but we don't have to worry about the nitty-gritty details because Johnny 5 does that. But yeah, Johnny 5 basically creates a serial communication between a node.js program and an Arduino, and then you write very easy to understand code, like turn LED on and stuff like that, and ultimately that will send messages over serial to the Arduino, but it has to be plugged in. All right, see you later, Depopam. Have a nice day. All right, I'm going to take a 10-minute break. When I come back, we're going to make this work, and then we're going to connect this to chat. It'll be fun. All right, see you soon. And before I go, Coding Garden is brought to you by viewers like you. I could not do it without you. So all the people that support me on Patreon and are members on YouTube, I thank you very, very much. And I'm going to show all of their names. So those will appear on the screen. I'll hide myself. I'll be gone for like 7 minutes, and I'll see you soon. That was the wrong thing. This Hello, friends. I'm back. I brought with me a battery pack. So this is a solar-powered battery pack. When I'll show... No, it's not over. We're still here. We just took a break. We're about to do some cool stuff. Let me let this end really quick. Cool. And what happened while I was away? Let's see. Thanks for the follow, Yusuf. No, it was just taking a break. Ditto. And thanks for the follow, Overlord. Cool. So this is a solar-powered battery pack, and it's just power. It's just power. So what I'm going to do is I'm going to take the USB that was plugged into my computer. So when I unplug this Arduino from my computer, it's going to stop blinking because it doesn't have power anymore. So I'm going to unplug it. It's done. But now I can take this end, plug it into my battery pack, and it starts working. See this. So really the main thing I'm demonstrating here is because we wrote this in C++, that program is now stored on the memory of this Arduino. And now whenever we get it power, it can work and it can blink this LED all at once. So that's great. And later on, it'll probably be like maybe 30 or so minutes before we get there, we're going to control this with Johnny 5. Oh no! And how that is different is because for Johnny 5, your Arduino needs to be plugged into an actual computer so that it can communicate. When it's on battery, I would probably need like a Wi-Fi chip to give it internet, and then I would have to program all of the network code in C++ to communicate with like a socket server. So Johnny 5 is a library for writing JavaScript that can control microcontrollers like the Arduino. So that. The other thing I've seen people do is you can take a Raspberry Pi, write your Johnny 5 code on it, and then plug your Arduino into your Raspberry Pi. Because basically the Johnny 5 programs you write would be running on the Raspberry Pi and then sending signals to the Arduino. So that could work to make it totally mobile. Because then the Raspberry Pi gets plugged into this. The Arduino gets plugged into the Raspberry Pi, and then I could put that anywhere. But the plan is, after we get this button working, we're going to make this thing light up. And we're going to make it so the chat can turn on and turn off different pixels. So that will be fun. But before we get there, I want to show how a button can work. So right now, we wrote a very basic program that turns the LED on and off. And basically, it's just on a delay. So we have this boolean is on equals true. Kobe Bryant passed away. That's unfortunate. Yeah, R.I.P. I didn't know that. Okay. But we have this boolean is on true. And then if it's on, we digital write LED pin to high. Meaning we turn the LED on. And then if it's off, we turn the LED off. And then every second, we just keep flipping the bit. We could try to do Twitch emotes on the grid. This would be very that would be very similar to what Lab 424 does on their stream. But yeah. Interesting. Brixus is saying the SB32, which is an Arduino with Wi-Fi built in, and use MQTT to have it stand alone. That'd be cool. Dang, he died in a helicopter crash. That's unfortunate. That's pretty cool. Yeah, I haven't really used any of these before. Oh, it's your code that does it. So we could do that, yeah. Because basically, I'm going to make it so that a certain chat message would turn a given LED on or off. So technically, we could convert an emote into LEDs on or off. But yeah. Cool. So what I want to do right now, though, is I want to hook up this button here. So I want to make it, instead of just always turning it on or off, I only want the LED to be on if the button is pressed. So let's get that going. I'm going to go to the Arduino website, and I'm going to look up their tutorials just on a button. Let's go to Resources, Tutorials, Built-in Examples. Probably Digital? Button. Use a push button to control an LED. Cool. So the Arduino website has this guide here. So we have our button. We do have a resistor. And I guess it's just controlling the onboard LED. So that's cool. Define button 2. So we need a 10K ohm resistor. And that's going to be used for the button. I think I have one marked as 10K. This one just says 10, but it doesn't say K. I'm assuming that it's 10K. But let's do a resistance calculation on this thing. To figure out if this is actually a 10K resistor, because that's what we need. Delay. Okay, so this resistor has 5 bands on it. The first band is brown. I'm pretty sure that's brown. We had a really hard time calculating our 220 ohm resistor earlier, but that's definitely brown. I then see 2 blacks. Black. Black. Then see gold. And then I see black. Oh, no, sorry, brown. That's the last one. 10 ohms. Oh, no, that's not 10K. That's just 10 ohms. We want 10,000 ohms, right? 10K, yeah. So this is way too little. We need more. Multiply this by 10. No, by 100. Toggle the light when pressed. Oh, we could do that. Yeah, turn it on or turn it off. Yeah, you're right. Yeah, because this is... well, no, this is a momentary switch, though. We could technically say if the button is pressed, keep it on. But if it's not pressed, turn it off, because it is a momentary switch. Debounce the button input. So we're going to use C++ to control this button. That's the plan. Dang, that's crazy. Okay, but we need to find a 10K resistor. That's not one. Oh, here we go. And this one is literally marked 10K. But we'll plug it into the calculator just to be sure. So, this one has brown. And then black. I want to say that's green. And then red. And then brown. This says 10.5 K ohms. Maybe it's green instead of black green. No. 10.5 is okay, says yes, sir. So it should work. It's interesting that this is actually, I mean, this just came in an electronics kit and it is labeled 10K, but technically it's 10.5. And I mean, this is like a darker green, I think. Is there a difference? I guess not, but this should work. So we're going to use this resistor for our button circuit. And here we go. So this is using pulse width modulation pin number 2. And let's see. I think they're just using it as an output, though. So the button pin is 2. And this is an input, because when the button is pressed, we want to send a signal so that way we can detect it. So that's the plan. Let's do it. Let's make this bigger. Let's get our circuit going. So we need this resistor plugged into just probably, we can do it on either this side or this side. And then the other one gets plugged into ground. Though that's really weird, though. So the way this circuit is set up is the resistor is plugged into ground. So we can see the brown wire goes here, and then the ground goes to the ground on the Arduino. So that's super interesting. But okay, we'll set that up, though. So we're going to take our resistor, and let's make this bigger. Phew. Look at the internals of the switch. I can't really see it on this one. Though, this is a bigger button. I probably need a smaller resistor. Because this is bigger than the one that they're using. Maybe I'll find a smaller one, just real quick. Just a second. All the tactile switches are the same? Okay. Yeah, because you can see here, I've got a whole bag of tiny buttons. Okay, Brixis is saying resistor size doesn't matter. Resistor size doesn't change with button size. That's good to know. Okay, it's just bigger. Bigger with the same circuit. So, we're going to plug this in here. So it has connections on both sides. We're going to take our resistor and plug it into this one here. So that's connected to that end. And then this end actually goes to ground. So we're going to put it on the minus, like that. And hello, Katoli. Welcome back. Okay, so now that's currently connected to ground, like it shows in the circuit. And then the other end, here, this one here, we need to connect to 5-volt power. So we'll do that. I have a red wire. And we're going to go from... we could technically use this power rail here, but right now that's the only thing using 5 volts. So I'm going to do the 5-volt connection on the Arduino here and plug that into this one here. Is that the right row? Yeah, that's the right row. So I now have 5 volts going to this side of the button, the ground connected here, and then now on this pin over here is what we need to connect to the general purpose output. And I have a link to how the switch works. Let's check it out. Ooh! So this example demonstrates the use of input pull-up. It monitors the state of a switch by establishing serial communication between your Arduino and a computer. Cool. Yeah, that's great, though. Doc is saying the resistor on the normally closed leg is so the input isn't floating. I have no idea, but Brixis has some comments. So button is binary, either on or off. When the button is pressed, the ground through the resistor gets pulled up to 5 volts. The resistor prevents shorting the power across the switch. I see. So when button is pressed, it actually does connect it to power. Okay, but what we need to do is we need a wire that will connect from the other side here to one of our output pins. So I'm going to let's use a blue wire. That will be connected here. So you can see on my circuit, I've got the blue wire connected to the other side. Oh no, actually this one needs to be on the bottom one. That's the same one as the resistor. So this actually needs to go here. Let's see. There. So technically, it's kind of hard to see because this resistor is like a little bent, but technically this blue one is connected across from the one that the resistor is on. And then the blue one we're going to put into, let's do pin out 7. That. They used pin out 2. We'll do 7. Just to be different. Okay, so for our codes, we need to set the pin mode. So very similar to how our existing code is setting the pin mode for the LED. So the LED pin is output. We need to set our button pin to input. And our button pin, we just plugged into 7. So we're going to set that as 7. So in our setup, we're setting our button pin to be input, meaning we're going to be receiving a signal from that button. That's great. And then the way we get whether or not the button is pressed is by reading from it. Oh, yeah. Missing the equal sign. Thank you, Polar Fluke. So button pin equals 7. Right now in our input pull up, do I really need that? In their example, they just did input. I want to leave it as input. We might need to change it, but we'll leave that there. And right now, I'm not going to control the LED. I'm just going to make sure that it works. So we get the button state. The button state comes back as an integer. And we can initialize it to, well, actually, we don't even need to store it as a global variable. It's just a variable inside the function. So button state, digital read on the button pin. So we are going to read from this pin that goes from the button to number 7 to see whether or not the button is pressed. And so we'll say if button state is equal to high, we're going to log, or just write to the console, button is pressed. So we grab the button state. If it's high, then the button is pressed. So for now, we're not turning the LED on, but I'm just going to see, do we actually see this print in the console? So here we go. Here's our serial output. We're going to upload. And I have a syntax error. What's it saying? Oh, we're not in JavaScript. We got to use double equals. Yeah. So let's see the serial. We should see hello world print. Cool. And if I press the button is pressed. And if I release it, we shouldn't see that anymore. And the thing right now though is I do have this delay in the loop, which is why it took a second before it actually showed button is pressed. Yeah. So it's working. This is a good thing. Yeah, this is going to be on YouTube. It already is. So if you go to my YouTube channel right now, I'm live on YouTube, and the stream will be here when I'm done streaming on the same URL. Thank you. Thank you, Alka. Cool. So now, instead of using this boolean is on, now we can actually use the button state. So let's do this. So if the button state is high, turn the LED on. It's weird tabbing. I guess it can be that. Else, we're going to turn the LED off. So we'll say digital write low. There we go. And then we can get rid of this. We can get rid of the delay. And basically what will happen now is the LED will only light up if the button is pressed. And then if I release it, the LED should turn off. That should be fine. Let's try it. Done uploading. Press, LED on. Release, LED off. Press. Look at that. Very cool. One thing we could do though is if we keep that boolean around is on, instead of only showing the LED on whenever we press the button, we can use the boolean to flip when we press the button, and that way if we press it once, button turns on, and if we press it again, button turns off. So let's actually do that. So let's have a boolean is on, initially is false, and then if the button state is high, that's how your house lighting works. Is on equals true. And if it's low, and actually, we need like the current state of the button. We can't really just toggle the boolean. Let's see this. Button pressed. I gotta think through how we're gonna do this, because when we press it, we want to flip it, but we don't want to flip it back whenever the button is released. Is this where pull up comes into play? Because that might do it. We could, I guess, flip it, but what I'm thinking is we have like a state variable. So the first time it's pressed, we say it's on. So I guess actually we also need like a counter, because if we press it, then it's going to be high. But then if we release it, it's going to go back down to low. So we need it to cycle. So if it goes from low to high, but it was just pressed, then we don't flip it. I think maybe 2 booleans would help. Detect the leading edge of the button press. Yeah, I think that's kind of what we need to do. So button state is, so if we pressed it, we're going to turn the LED on, and we're just going to use the is on boolean for that. And then we're going to say button pressed equals true. Like this. I mean, really? I got to think through this. We only need 1 boolean. This is going to be, I think this is going to be easier than what I'm thinking. But let's work this out. So first, let's just get the LED working. So if is on, then write the LED pin to high. Else, write the LED pin to low. So if is on is true, it goes high. So let's just do this. The first time we press it, it's going to go to true, and it should turn it on. So let's go. Upload. Okay, so we press it. Now it's on. It's on forever. But what we need, I don't want it to turn off when we release the button. Oh, I see. We don't have to look for button state. Yeah, you're right. This is a lot easier than I thought. We literally just flip is on right here. Because when the button is pressed, it'll do that. Cool. So it should be off initially. On. Yeah. See, this does what I was doing earlier, because when we read it, like, it has to be pressed in. Right? This is how it was working earlier. Yeah, Spartan. So we talked about this earlier. You can use C++. Yeah, so I think we do need button state. Let's go back to what I had. Yeah, so and we mentioned earlier, if you use Johnny 5, which is the JavaScript library for doing it, the code isn't running directly on the microcontroller. It's communicating over serial on the USB. So here we go. So now it should be, I press it once, and it stays on. So this is good. And then I think we need another boolean for our button state. Not button state. Button pressed. That equals false. Equal button pressed true. Okay. And then when the button is pressed again, we turn it off. So I'll say something like this. Else button state equals low. No. If button state equals high and button state is not pressed, then we turn it on. Otherwise, we'll just say button pressed equals false. We can do this. I'm making this a lot harder than it actually should be. And also, I'm kind of mad about this indentation. Why is that so little? Toggle. It doesn't work that way because is on will get. It's for some reason it's getting set back to false. That should have worked though, shouldn't it? If button state is high. Okay, first off, before we go down this path, I'm curious why this didn't work. It should, we are stuck. It shouldn't be this hard. It really shouldn't. But what we thought of is just flipping is on to not is on. I feel like this should work. So initially, it should set it to off. So it's false. And then when I press it, button state is high. So it goes from, oh, you know what? It's happening way too fast. Yeah, it's flipping it. It's flipping it. Yeah, so if button state is high and it's not on, then is on equals true. Yeah. Yeah. It's just basically happening way too fast. We could do a delay. Like 500 milliseconds. Put that at the bottom. Or even like a second. So that way it's like a momentary press. The button is swinging. So I'll do one press. Oh, no. We only want to delay if we flipped it. Yeah, it's because we're overriding it like instantly. One press, now it's on. One press, now it's off. Cool. And maybe we can even do like a slower delay. Let's do like a 100 millisecond delay. Because the main reason is it was happening so fast. So one press on, one press off. Oh, it's not quite enough. 500 milliseconds. One press on, one press off. One press on, one press off. Yeah, that's good enough. All right. That's good enough. Okay, so here's what I want to do. So this program we wrote in C++. It's running inside the Arduino IDE. I want to write a very similar program, but we're going to use Johnny 5 instead. Open up the button press demo and see how they do it. No, so they were doing it as a momentary switch like I did it earlier. Do the delay before it is on. Yeah, I mean, and then technically, I think I want to do this. Read the button state, then do a delay. I don't want to delay in the loop, I don't think, because I really only ever want to delay if I press the button. I think that's why. Cool. But what we're going to do next, write this same program but with Johnny 5. So this is C++. The program is running directly on the Arduino. And that works great. But I believe their example here that we were looking at, the button example, this one is a momentary switch. So you have to hold the button down for it to turn on. And then whenever you release it, it turns off. And so right now, when I'm holding it down, it's just going on, off, on, off. Used exclusive or? Yeah. Oh, keep track of the last button state. Yeah, that's probably a way to do it. When we're writing it in JavaScript, maybe we'll do that. But okay, so let's do that now. So what we are going to use is oh, could you even see that? Yeah, you probably couldn't see that very well. Johnny 5. This is not going to give us good results. Johnny 5 JavaScript. I think I spelled Johnny wrong. Here we go. Johnny 5. The JavaScript Arduino robotics and IoT platform. Thank you, Sigurd. So, like I mentioned earlier, this allows you to program the Arduino using JavaScript, and the code is, you could say, probably a lot easier to understand than C++. And they give you like high-level functions and like callbacks that are going to get called. It's cool. So, let's do it. So, I'm going to close the Arduino IDE. turn that light off. And here's the thing. The other thing I'll show you is if I've now unplugged this from my computer, right? Yeah, and we're gonna plug it into the battery pack. And now because this is plugged into a battery pack, the program is still running on the Arduino, so our turn on, turn off still works. Yeah, cool. And thank you, Sonam, who says my full stack video was really helpful. That's good. Yeah, we mentioned Esperino earlier. It's embedded hardware, but it actually runs JavaScript directly, which is pretty cool. So Vinny is going to port my Domino Pizza API into Roblox. I've never heard of Roblox. I don't know what that is. That's cool. Okay, but let's get Johnny 5 set up. So I'm just gonna get like a node.js project going. Make their Arduino fun. All right. I'm just gonna make a new directory. I'm gonna call this LED button. We'll initialize it as a regular Node.js project. So when you're using Johnny 5, it's just JavaScript. Everything you know about JavaScript will just work. So we're gonna install Johnny 5 in this directory. Oh, and I brought mochi. I'm gonna eat this mochi. It's melting actually. Whew, that's really good. It's caramel flavored mochi. Cool. So Johnny 5 got installed. Now let's open up VS Code in this directory. Now this part has my interest. Yeah, but what is Roblox? I've never heard of that. So a game platform where they host your game. Some people make money from making money on Roblox. Interesting. Yeah, if you just search on my YouTube channel for Order a Pizza with JavaScript, I basically looked at the network traffic on the Domino's website and made a JavaScript library for ordering pizza from Domino's. And yeah, so the stream is going to be available at the exact same URL that you see right now. This stream will be there after this is done. Polar Fluke says, I love seeing streams like this. It really screws with my productivity for the coming week or many. Is that a good thing? Because that means you're interested in stuff? The pizza thing was like a year ago, I think. Yeah. Yeah, I've done this before, Win32 0 day. So there are plugins for VS Code where you can program the Arduino. Yeah, I just wanted to show the IDE because that's where most people get started. But a while back, I created an emoji keyboard. Let me grab it really quick because it's pretty cool. So this is a while back. I didn't create it on stream because it was actually really hard to do. But this is just a regular keyboard, and I put emoji stickers on it. But what I did was I got this Arduino shield. I will show you. This Arduino shield allows you to plug USB into it. So it's a shield that can receive input from a USB device. So I basically, this Arduino is now just like a USB controller. And when a signal comes from the keyboard, the Arduino, through the USB, will actually output a keyboard signal to the computer. And I send a sequence of Unicode characters. But the reason I mention this is because when I was coding it, I used VS Code. So like I used all the plugins and stuff like that. Yeah. And thanks for the follow, the Doubler. Will this compile your JS to C ahead of time and load onto the Arduino, or is there some no, it's all done through serial communication. There is no, like, JavaScript is never actually running on your Arduino. Yeah. And thanks for the follow, J America. And thanks for the YouTube sub, Brian. Yeah, it's fine. We're a small community here. Okay, let's see. I'm interested. So, because we got this this button toggle working earlier, but we had to use a delay. Oh, my power isn't on. There we go. So turn on, turn off. But let's see the example that Brixis is mentioning. Yeah. I think the code for it is on GitHub. It was really like I was basically writing a keyboard driver in C++. I've thought of easier and better ways to do it now, because basically I had like this giant map of like key code to Unicode characters. It was a mess. But what I was thinking now is I could make like a desktop program and just communicate over serial from the Arduino. So the desktop program would allow you to set which key is which emoji, and then instead of actually emulating a keyboard, it could just send a serial message, and then the desktop program could like inject a key. That would probably be easier, but it was fun coding that thing for sure. Who mentioned it? Brixis. Okay, file. Examples. Digital. Debounce. Okay, this is like for debouncing a button. Let's see. So read the button pin, and then yeah, so there's like a delay. Mine is like much simpler than that, but this is good because basically after reading from the button, it has a small delay before it would ever read again. Cool. Whereas mine just delays 500 milliseconds. It's pretty simple. Oh, the power turned off. Come on. Power on, power off. Cool. All right. Okay, now we're gonna use Johnny 5. Oh, what did I do? So we made it so that I can press a button. Oh, the battery keeps turning off. That's not cool. But I can press a button to turn the LED on and press the button to turn it off. But we did that in C++. Now we're going to try to use Johnny 5. Let's do it. Okay, so we installed Johnny 5. We need to write some codes. Let's do it. We're going to use const instead of var. So we bring in Johnny 5. Make these single quotes. We create a new board. So we just say 5.board. And then when the board is ready, we get this callback function, and we can do a thing. So in our code, in the C++ code, I remember we had a variable for the pin of the LED. So right here, the LED is plugged into 12. So we'll do that in Johnny 5. So we want an LED that is 12. Here I can say LED dot, not blink, we'll just say LED dot on. And that should be enough. So, like I mentioned, before I erase this program that's running on my Arduino, like right now, the Arduino is just plugged into a battery pack, and I can press this button and the program runs all day. That's great. But now we're gonna use Johnny 5, and this requires the Arduino to be plugged into my computer because the Arduino can't run JavaScript directly. So we plugged it in, and now we're gonna run this program, which should just turn the LED on. That's all it should do. So clear this, run it. Connected. Nothing's happening. Let's see. A timeout occurred when communicating with the board. Oh, do I need to flash custom firmware? What? Seriously? I guess I might have to. Yeah, they're saying I need the Johnny 5. Yeah, so this is the Fermata firmware. Okay. totally forgot about that. Let's do that. And the thing, I have 5 Arduinos here, so it's okay if we flash one. Upload it from the Arduino IDE. Okay, I remember doing this. So basically, you load a C++ program into the Arduino IDE, write it to the Arduino, and now the Arduino basically has a program that is listening for serial messages from the Johnny 5 program. That's like the custom firmware. So let's do it. Yeah, we have node.js, we have Xcode. Where is it? Firmware. Okay, so this is Fermata. Yeah, so file examples Fermata. Let's do this. File examples Fermata. Which one do we want? Standard Fermata Plus. This one. Fermata is a generic protocol for communicating with microcontrollers from software on a host computer. So, we're going to upload this. That's basically it, Doc. Yeah. So now that it has this firmware, whenever we start up the Johnny 5 program, the Arduino is literally just listening for serial messages. And the Johnny 5 program is very simple, right? We just say, hey, I want an LED and it's on pin 12, and hey, I want to turn the LED on. But under the hood, the Johnny 5 library is actually just sending serial messages that will actually turn things on and off. So, initialized LED on. Awesome. So that was easy. But now that we have the Fermata program running on there, I can't just plug this Arduino into power. It has to be plugged into a computer running like a Johnny 5 program. How do I get out of here? Exit? There you go. You can just barely see. Oh, sorry. I'll just run it again. Let's put this here. So it's running, and then when it runs, the LED turns on, right? But if I ever kill it, the LED will turn off, I believe. I'm not. But let's talk to the button now. So let's look at Johnny 5's API. I have no idea, Doc. I really don't know. So we're going to look at button. So we have a button plugged into pin 7. And so if we look at our original C++ code, button pin 7. So we're going to create a new button inside of our codes here. So when the board is ready, we have our LED. We have our button, and we want this on pin 7 because that's where the button's connected to. And then let's see what we have available to us. Button dot up value, probably? Down value? So we want to know if the down value is a given thing, then turn the thing on. Most likely. Let's see if they have some example code. And I do believe we have these plugged in the same way. Yeah, like this pin's plugged into ground. This one's plugged to power. Yep. Ah. Yeah, and so so we need the event emitter. And the cool thing about Johnny 5 is they've done some higher level stuff for us. So before with C++, we saw we were having an issue where the thing would instantly, like, because the code was running so often, it would instantly like turn on and off. But now instead of listening for hold or release, we can just listen for button press. And that's only going to get called once, or it should at least. And so we can just say, like, when the button is pressed, turn the LED on. And we can also have a boolean, so we'll just say, like, let is on initially equals false. And when the button is pressed, if is on is true, then we'll say led.off. Else led.on, and then we're going to flip is on every time. So we'll say is on equals not is on. I'm just going to log here, button pressed. So when we press it, if it is on, turn it off. If it wasn't on, turn it on, and then the next time around, we'll flip it. So this should give us the similar behavior that we had with C++. Let's try it. Okay, so it's off. Press the button, turns on. Press the button, turns off. There you go. So that's awesome. So same program, just written with Johnny 5 instead of C++. And I feel like I've said it 10 times before or more, but again, this code will only ever work if my Arduino is plugged directly into my computer. So on, off. And I can even hold it down. But what's cool about this press event is it's only going to get called once when it is pressed. That could work too. Yeah, I'll do that, Brixis. So initially it's off, but instead of having my own separate boolean, Brixis is saying LED dot is on state. I don't know if it works like that. We do have to call a function. Yeah. Let me just look at the API docs for LED, because we probably can get the state of the LED. Turn the LED on, turn it off. Oh, toggle it. Toggle the current state. Yeah. that's a lot easier. So we could just say led.toggle and then flip oh no, that's literally all we need. led.strobe. Well, that'd be cool. But let's see what this does. Just gonna exit, restart it. And so now toggle it, toggle it, toggle it, toggle it. Cool. All right, so as you can see, this code is much easier for the most part. But now what I want to do is I want to control this thing. So I got to figure that out. We did find this one article for the Arduino. This one, not this one. This one, not this one. Yes, one. That shows how to control it. Strobing is blinking. Let's actually just blink it, because that'll be fun. We'll let that blink while we're doing this. So I'll just do. We don't need the button. We don't need the LED. We'll see led.strobe, and then we'll run this. Look at that. Look at that. So that's fun. So this is a tutorial on how to control this thingy using C++ code, but potentially we can adapt it. Like if I just look and see what's happening here, like we have pin mode, we're using all of the analog pins, and all of the digital pins, and we're setting all of them to output. And then we're just like writing a row. This is actually really easy. Okay, so what I'm curious about though is we're not using any resistors. Like this is plugging all directly in to all of the inputs and outputs. It might be that the circuit itself has some resistors on it already. Does anyone know? But also, I get to do that sweet, sweet feel. Cool. Oh, sweet. So Johnny 5 literally has an LED matrix one. Let's check it out. So if we look at this, LED.matrix. Nice. That's just too easy. This is what I was mentioning though. So we have this microchip that it came with, and I think we need to use this. Oh, you can't. Oh, I think you missed the pill. I need to make this smaller. It's like in the way. Use with the Max 7219 chip. I think that is the chip. let's see if it gives us use without it, because then we can just plug into all of these pins directly on the bottom here. Let's see. This makes it way too easy. This is so like, you can literally send it an array of what you want the pixels to be, and it'll just work. This is like, it's too easy. Okay. The Max 7219 chip. So let's look at this thing. Make this bigger, and I'll change the zoom so we can actually see the chip itself. Make Johnny 5 myself. Like, I'm not like, I definitely could. Or we can make like a small version of it. Yeah, because like, check it, like, you really could though. So like, there are npm modules for communicating over serial. Like, if you just look up serial communication, yeah, like serial port, access serial ports, welcome your robotic JavaScript overlords. And then we could just read and write from serial, and then we could have we can write a C++ Arduino program that's listening for commands and do something. But yeah, regardless, we're not gonna do that. Let us zoom in and look at the serial. We're gonna look at the top of the chip here. And also, I'm gonna kill this program, and I'm gonna unplug my entire circuit. So we're done with this. This is great. We got all that working. Now we're gonna get this thing working. Okay, so unplug all the unneeded things. All the wires go away. All right, and really, we just want to get a really close look at this chip here. We need to adjust the zoom, but what I'll show you, who needed power anyways? What I'll show you is the chip has some writing on the top of it, and that writing will actually tell us like the type of the chip, which will inform us how we need to actually wire the thing up. Okay. Oh, it froze. Cool. I don't care about YouTube. I do care about YouTube. Are there any YouTube chats? YouTube chat is broken? Well, that's unfortunate. Let's see what happened. I do care. I absolutely do care. We probably got an error response from the YouTube API at some point. Here it is, and it says unhandled rejection, connection reset. Lame. Okay, give me a second. There we go. YouTube is back. I should probably fix that. And look at all those drops that just happened. Save us. Let's see what else I missed. Digital pins do have 20 key resistors. However, it won't hurt to put your own. Oh, okay, cool. It's good to know, Ben. And hello, Hassan. All right, and hello, Oscar. All right, what we were about to do is figure out what chip this is. So I need to get the focus working. You've been saved. Webcam control, focus. This is actually extremely hard to see. We're gonna go like super close up. Yeah, you can't really even see it. Maybe if I point a light at it. Yeah. All right, give me a second. We're gonna make this work. And get super close. Oh, there you go. Yeah. So there's a number on there. Let's see if I can get it right. 1838 HXL L4 or E4. And then there's SN74HC595IN. Texas Instruments. Yeah, that's what that little Texas sign is. So that's the chip. And if we look it up, we should be able to find like how it needs to be wired to this board here, if we need it at all. If we need it at all. Okay, let's adjust this. Let's go back to where we were. Don't I really need the datasheet of the display rather than the chip? Probably. We'll see. Where's that Arduino at? There we go. Yeah, because this says the Max 7219 chip. Oh. It's a shift register, so you have less pins. SN74HC595N. 74585 is what we need to look up. Where did we see that? I don't see that on here. And then this thing has 1588BS written on it. This thing does. And thanks for the follow, Freda. I set up low latency streaming on YouTube, so technically it actually should be pretty low latency. No, I have ultra low latency enabled on YouTube streaming, so that should be there. Okay. Cool. Now, what do we do? Component initialization, shift register device. You say the pins, data, clock, and CS. So there's only one, two. Oh, you know what? I think we could just use. Wait. There's 1, 2, 3, 4, 5, 6. No, there are 8 pins on this thing. This is showing 1, 2, 3, 4, 5, 6 pins on this one. So it's not quite the same. Interesting. If you're working with HT16K33 devices, 74 is a series of chips, but 74 followed by the next 2 to 3 digits is the base part of the number. Okay. It's 27 seconds? That's crazy. Yeah, what I'm thinking is this chip I have here is the same one as this chip there. So the 7219. No, it's different. Honestly, I don't know how to wire this up, which makes me think that like I could technically just do this and then we control each individual LED or something like that. Let's see. Thank you, Win320 day. Let's check it out. There you go. I need to wire each column cathode to the digit/row pins of the shift register and the anodes to the segment pins. Where did you find that, Doc? Using the 74HC595 to control an LED matrix. That's the one I have. Yeah, 74HC595IN. I have a different number on top, but the bottom number is the right one. So that's good. Wow. Okay, this is a lot of wiring. We could do it though. It'll be fun. And thanks for the Twitch follow, XX Levels. Though, the top number will be different. So is that like just like an individual part number or something like that? Yeah. Let's get to plugging. The YouTube picture-in-picture is way too small to watch comfortably. That's unfortunate. Okay. Make a winking emoji on the LED. So that's the Arduino. This is the chip. We can see the notch is on top. I don't know what that tells us, but my notch is here. In relation to the diagram, I think notch means that it would be up here, possibly. Okay. And then, it's using Arduino. Oh, chat is slow. YouTube is fast. Okay. Notch is up pin. On left top is 1 pin. It's pin 1. So, looking at this, because the notch is over here, so the notch is here. We're saying pin 1 is the top left one. Left top pin, pin 1. So this is going to be pin 1 right here. Because the notch is here. I know it's hard to see on my camera, but yeah. I also need capacitors on the power supply pins. Let's just try to interpret this thing. Yeah, 330... Is this a capacitor symbol? Okay. Here's the thing. So we have that. That's great. But if I go back to this article here, they're just wiring it directly to the thing, and that seems a lot easier to me, right? They're just wiring it directly in, and then setting the output mode of each one. A 330 ohm resistor. Okay. Because this one, it's a direct plug-in, and then they're sending a byte value to that particular pin. Because if we see like byte A is an array of bytes, and then they're gonna draw A, R, D, U, and so is that how you do that in C++? You have the variable name with the bracket around it to make it an array. But they pass in draw screen. And now what does draw screen do? It does a digital write on that row to be high. And then for each individual byte, it grabs the column, does some fancy stuff here, and writes that to it. So that's determining like which LED in the row or the column is lit up. Like, to me, yeah, I like this better. And I think we could potentially convert this to work with Johnny 5. I want to do that. I want to throw this chip out the window. We're going to plug directly into the Arduino. That's the plan. Yeah. One issue, though, is when I plug it in, I don't have access to the pins that it's plugged into. Let me see if I can find a better breadboard. Oh, the other thing is, I actually don't necessarily need a breadboard because I could use some wires like this. So I'll show these wires. Yeah, and I'll show you why it doesn't fit. So you can see the pins are on the bottom there, and I need those to each be on a separate connection, so a separate row. And so when I do that, they're all hidden from me. There's no way to connect them. I need a wider breadboard. But I could use a wire like this. So this wire could whoa, buddy. This wire has these connectors on it, which will plug directly in, and then the other end could plug into the Arduino. So technically what I could do, please stop, is I could plug these wires like into this side. Like so. and then the other end directly into the Arduino. I think that's what we're going to do. I see. Shoot. Why did Mattia say shoot? Is he talking about the drop game? I think I'm going to do this. So instead of a breadboard, I could literally just plug this in and then plug it in. So I need 2 wires like this. I need 8 wires. 1, 2, 3, 4, 5, 6, 7, 8. So I now have like an 8-wire ribbon like that. I can plug all of these in on one side. Does everyone agree that this is a potentially good idea rather than using a breadboard? Just snap the breadboard in half. There we go. So what I have done is I now have a ribbon cable that's plugged directly into the back of that. We can do that, and then I just need another similar cable. We'll plug it in the other side, and we'll plug all those in. Why is it called a breadboard? I don't really know. Does it look like a loaf of bread? Actually, yeah, I could do this. I could put 2 breadboards side by side. That actually would work. Let me see really quick. Yeah. Wait, will that work? So here's 1. Here's 2. I need each of these. I don't think that'll work. No matter which way I spin it. Because if I do, well, no, actually I could do this. Yeah, you're right. I could do this, and then hopefully if this matches up on this side, let's see. And these actually connect together. That's pretty interesting. Yeah, so I got that. And then now technically I could take this and put it on here. Yeah, that actually does it. Like that. Because now I have access to the pins here and there. I don't know. What do you think I should do? So should I just plug the wires directly in, or should I use the breadboard? You break bread, you break boards. No, these are just smaller breadboards that I have. They came in a kit. Oh, a wooden or plastic board on which dough is kneaded or sliced. Use the breadboard. Okay, I can use the breadboard. The only issue here is I need to leave it sticking out a little bit just so I make sure that I have the right wires plugged in. Cool. And then if that's the case, I need wires that have the pointy end on both sides. Breadboard looks better? Okay. Slap a power rail in the middle and make more room? What do you mean? I vote for you to eat another mochi. Cool. Yeah, so I believe the way it works is you send a specific value to that pin, and that determines which LEDs on that pin are lit up. Yeah, and that's true. I could do more stuff out here. Okay, we're gonna go with that. I'm gonna go get some more wires, because I want to have like a ribbon, an attached ribbon cable, because right now I have a bunch of like little spare wires. It'll be nice to have 2 ribbon cables. That won't do it. I might have cannibalized all my Oh well, this is gonna get messy. This looks like the easy. Oh, it's like literally an embedded microcontroller with the matrix. Ah. Yeah, so it's this module here that you then just plug. You need like 8 wires, I think, probably. Yeah. The LED panel has 16 pins. So I think it's 1 for each row and column. Yeah, something like that. We'll figure it out. Though I couldn't find any other wires, so we technically need 16 little wires like this. You just count them up. May not have enough. At least of this kind. 3, 4, 5. 6, 7, 8. 9, 10. 11. 12. 13. 14, 15, 16. All right, we have a pile of 16 wires. Step 1. Doc is saying, just want to make sure you're limiting the current below 40 milliamps, which is the max each pin can do, I think. One of the advantages of the shift register is it's rated for 500 milliamps. Okay. I'm not sure if the serial port would be able to keep up with multiplexing of the image. You might need to write the code in C++ if I omit the shift register. Ah. Multiplexing. Yeah. Okay. Well. The issue is I want to use JavaScript because we need to contact an API to get like the chat to be able to control the stuff that's on it. Okay. So maybe I don't go down this route. Maybe we do try to use the shift register, but I need to figure out in the Johnny 5 documentation what that means. So this has 6 wires coming out of it plugged into the Arduino, right? And if we look at this, there are many more wires plugged into the Arduino. So it's definitely different, right? Yeah, most likely. Though I think I'm just gonna Google it or search it. So Johnny 5 that thing expander. Oh, there we go. I can do this. This is a nice diagram. Let's do that. Though this, I mean, this is controlling just a bunch of LEDs, but we need to technically control a matrix. But this is the chip. And this is the connections. Use a 74HC595 expander as a virtual board, 8-pin digital output. And then all of the wires here, I mean, this technically does have the resistors. Yeah, I use DuckDuckGo, not Google. It's like a verb at this point. This is 4 pins on each side. So, I mean, I think this part is probably right. We just need to figure out what pins get connected to this thing. This thing. Okay. All I need to do is repeat that 8 by 8 times according to LED matrix wiring diagram. All right, this is going to get complex. That's fine, though. We got time. Duck it. Duck, duck, go it. Column, row, quack, quack. I don't know what I'm looking at. Not all, I don't always end up going to Google. Like this first result on DuckDuckGo. SB46, also known as Imphy, is saying to Google something is officially a verb in Germany, freeing them from copyright. Wow. We're going to Google. LED matrix with Johnny 5. Okay, so we've already looked at both of these. No, this is the tutorial. Each row anode to segment pin is on the chip. Each column cathode digital pin on the chip. Okay. This doesn't help. This doesn't help either. LED array? Well, no, that's 3. Shift register. Yeah, this is different too. It has a different connection. Okay. If I use this, do I need resistors? I think I do, because that original one that we found, this one, has a resistor setup. Though those are being plugged into the digital out. It's not going to the board itself. I see, so the rows are plugged into the chip, and the columns are plugged into the Arduino itself. I can always watch a YouTube tutorial. Are there any? I don't know if there are any. Let's just look. Because they might have like a tutorial link. So this Johnny 5 LED matrix. LED matrix control with Johnny 5. Let's see. That looks like the chip, right? These diagrams are the reason I left IEEE. Okay, they did not... Oh, that's great. They didn't link to their code or anything like that. That's fine. 8 by 48? No, I want an 8 by 8, but it might be similar. Okay. Oh, they're typing instructions to us. That's pretty cool though. Look at all of them. Okay, we're gonna figure this out. I think we start here. We start here and get this wired up, and then the chip datasheet beckons. Did I already have that open, or I guess I didn't? Ah, here we go. Serial interfaced 8-digit LED display driver. Wait. Is that meant to control this? Though, well, this has 12 pins on it. This thing. This thing. We have to do this in Pascal. This is not the Max 7219. This is the... Where'd it go? This one. It's the other one. Yeah, it's the wrong one. Oh, what did I do? Oh, I closed. This. All right, we've kind of just been sitting here doing nothing for a while. I think we gotta start. We gotta start doing something. Not this. I think we're gonna start here. I'm just gonna plug the chip in, get it wired up the way it needs to be wired up. and then go from there. So that's the plan. So let's do it. One of our pins is slightly bent. So how should I do this? I think I'll plug the chip in here. Thing to think about is, oh, you can't even see that. Plugging the chip in there. All of these pins essentially, well, no, not all of them. 8 of them are being plugged into this thing. And really, should we just be using this diagram? I think we should just be using, we're going to use this diagram. Okay, and how do I tell if it's rows or columns on this thing? There's writing there. And thanks for the follow, Lemurs. The chip is of a type called a shift register. Okay, there's a diagram. The shift register holds what can be thought of as 8 memory locations, each of which can be a 1 or a 0. Okay, so we have an 8x8 thing. To set each of these values on or off, we feed the data using the data and clock pins of the chip. I see, so it's like a stream of data to set like 8 bits. Right? The clock pin needs to receive 8 pulses at the time of each pulse. If the data pin is high, then 1 gets pushed into that shift register. Otherwise, it is a 0. When all 8 pulses have been received, then enabling the latch pin copies those 8 values into the latch register. Okay, that's cool. This is necessary, otherwise the wrong LEDs would flicker as the data was being loaded into the shift register. The chip also has an output enable pin that is used to enable or disable the outputs all at once. You could attach this to a pulse width modulation cable Arduino pin and use analog write to control the brightness of the LEDs. The pin is active low, so we can tie it to ground. That's good to know. We learned something. Thank you, Brixus. And hello, Stablum. Interesting. Okay. Though I believe this is the one we want to follow. I wonder, do they give us Arduino code? They do. The characters. The pins. And that makes the smiley face. This is a dedicated guide. Okay. One shift register. Okay. Connect to the Arduino, add 8 LEDs. Oh, I see. So each of the 8 outputs is connected to this thing. Instead of just 8 plain old LEDs, it's 8 rows or 8 columns, I believe. Two shift registers. Wow. Okay, that's cool. We'll leave that open. Who said you need anything of those? Wait, what? Oh. Is this the Tinkercad thing? Does it actually have a diagram? The thing is, if it's working on here, I can just follow that. The page has expired. What the heck? Can you resend that? To control that matrix, you would use 2 shift registers to control column and row. But would that mean I need 2 of these chips, though? It's not working. Lemors is saying I can do it without shift registers. That's why the schematic, the other 8 pins are connected to the Arduino. Okay, like in this one, 8 of the pins are connected directly to the Arduino. The other 8 pins are connected to the shift register. And these pins are being used as a shift register? Ah. Ah. Would this technically work though? So I mean, it's like 8 connections to a row and 8 connections to a column. So is this technically the same thing? It's just wired up that way? Because this, not this one, this example that we saw, just plugs 8 wires directly from this board into the Arduino. The shift register selects the row. The columns are connected directly to the Arduino. Okay. Start the simulation. Huh. Stop the simulation. Let's look at the code. So we have rows and columns. Our analog outs. Let's see. Analog outs are potentially plugged. So the main thing is I don't know which one's the rows and which one's the columns on here. I need to figure that out. Let me look up this pin. The data sheet for this. 1588 BS LED matrix. Finding pin 1. Let's do it. Let's figure out how to find pin 1. Looking at the diagram, we see that the rows correspond to under the side pins and the columns correspond to pins. Okay. Pin. Wait, what? Yeah, this is what I'm seeing. That thing. Based on the schematics, this should be the front side of the matrix. Okay. Keeping the direction constants, we will now begin sending power and ground through the pins closest to the sides of the matrix until we find which combination illuminates. So light 5 and 8. Wait. Yeah, there are 8 pins. Huh. With the LED in row 5, column 8 is illuminated. We can now safely assume that the pin connected to the black LED ground is pin number 1, and the pin connected to the red pin is 16. So I think, we're looking at this as pin 1 and this is pin 8. Let's try it. Is this, how much power are they supplying to it? But I think that's pin 1. I think we'll try to do the same thing. Also, I have one extra one, so if we break this one, we have one more shot at doing it better. Okay, so what I have learned is that this go through a 220 ohm resistor. Okay, I'll do that. Most likely, this is pin. You can't see it. Sorry. Most likely, this is pin 1. That's what I think we figured out. But let's grab ourselves a 220 ohm resistor. Yeah. We'll just plug this up and we'll plug a wire from it. So we're gonna go from here to here. Plug our Arduino in. Plug one cable from the 5-volt. Into the power rail. And then one cable from the power rail to the resistor. We also need a cable going from ground. We'll plug it up to the ground on the Arduino. Plug that up to ground here. And then we'll need a cable going from ground here. Okay, so that's ground, that's power. We'll have one wire coming from out of the resistor. Yeah. And then another one plugged into ground. So what this is telling me is if I plug the power into the last pin over here and then this one into ground, this one's going to go to ground. Wait, no, this one goes to ground, which is this one. So that plugs into this one. I think is pin number 8. And then this one, the power, goes to the pin on this side, which is this one. And nothing has happened. Okay. Thanks for the follow, eyebrow. It's not lighting up. Does that mean it's broken? Let me pull out my other one and see if that one works, because it could be that this is just broken altogether. Here. Yay, nerd stuff. Unplug these. I did not get this from Adafruit, no. It came in like an electronics kit from Micrositter, actually. There. So this has our power. And it is plugged into 5 volts. This has our ground, and nothing is happening. I've done like basic electronic stuff for a while now. Eternal Dev says, I got my LEDs to blink on the breadboard and the Arduino at the same time. That's great. Great work. Reverse the power and ground. LEDs won't break if you hooked up backwards. Yeah, let's try it. This one goes. It's so hard to see where they actually plug in. Like that one needs to line up with this pin. There. And this one needs to line up with this pin here. Oh, that did it! Yeah, so they're backwards. So that I think that what that means is pin 1 is actually this one. Cool. But if we compare that to what they did, wait, it's 4 from the bottom. Yeah. But this one, this is our power, and this is our ground. But does that mean we can light up each individual LED? Yeah, so that one does that one. That one. That one. Yeah. Okay. Shouldn't break. They rotated their thingy. But I feel like in their diagram, this red wire should be coming from power, right? They wouldn't mess up. Like, they wouldn't mess up the power and the ground plugs, would they? I don't know. I don't. This is the first time I've ever streamed anything related to Arduino IBOW. Yeah, it's special. Yeah, I definitely need to change the wire colors. But let me just verify what they did here. Okay. Yeah, red is connected to power. Black is connected to ground. We know that for sure. So, does that mean... What does that mean? Because basically, I have ground connected to the top left. Oh. We look at it like this. So if we look at it like this, my my ground wire is, yeah, let me use a different color. We're gonna use like a green or a black for the ground. Because this is technically brown, but it looks orange. Here's a black one. Black for ground. So connecting our ground to this pin when that thing lights up. Okay. So actually, I mean, honestly, I could just flip the chip around to try to make it look like their image. But for them, ground is the bottom left. So weird. I'm just trying to identify. I'm trying to identify the board, the pinout for my. I don't know. So I have a number, and I searched that number, which is, yeah, it's this one, the 1588BS. Yeah, that's what I'm trying to do. I'm trying to identify pin 1, and I was trying to follow this article, but it's confusing because we plugged our ground and our power in on opposite ends, and we got the same LED to light up. Power can move one more left. And move ground all the way to the left. Yeah, see, for me, this nothing lights up when I have my my ground plugged into this one. Oh, Oh. Let me show you what I'm looking at. So this is my ground. It's now the second from the left, and I am getting other things to light up. If we go one more over. Connect pins 9 and 13. That's the issue, X Matrix. I don't know which one is which pin. I don't know which is pin 1, which is what that article was trying to help us figure out. Yeah. Yep, so if you look on my YouTube channel, this will be up there later. Okay, Xmetrics is saying, pull the chip. Look at the bottom. Nothing. Are you trying to rickroll me? Saying this might help. Oh, is there a dot on it? I don't see a dot anywhere, though. See? Nothing. It's not very helpful. Pins are almost always denoted, but they're not. They're not. Let me get this out of the way. I'll just show you. This is what I'm working with. Okay, Infy has an idea. Monthly Arduino stream or maybe other embedded electronics. Yeah, I'd love to, for sure. We could do more cool stuff, and I could do more research prior to it, because I didn't plan this, and I have no idea what I'm doing. And it seems to be very hard to actually find resources. Flip it. The letter side is 1 through 8. That's what I thought, too. But the power and the ground are reversed versus what I was seeing in that article. A divot, a dot, a unique identifier. Oh. Sort of. There's this this on this side, which means that this would be pin 1. Is that what that means? A divot. Unless they're I mean, this is a cheap thing. Hey, calm down. You'd bet your money that this is pin 1? Okay. Well, let's just do it. Let's just pretend. Let's just not pretend. We're going to assume that that is pin 1, especially because that's where the writing is, right? The writing is there, so I'm going to assume that one's pin 1. Yeah. We're going to assume that that is pin 1. And then, what were we doing? Oh, yeah. We were going to try to hook things up in this fashion. So let's do that. Do I actually need... Well, they're plugging this without resistors, though. What am I looking at, Alka? Yeah, so that's the image I saw before, and I mean, I guess I'm assuming because the writing is on this side, it's different writing, that this is going to be our pin 1. I'm going to go with that. We're going to go with that. And then, do we decide on using the chip or not using the chip? Positive, negative. All right, we're going to try to, I think we're going to try to use the chip. I think that makes the most sense, right? Because then we can use Johnny 5, we can do the shift register thing, and then when I get it working, I'll take pictures of it and post an article about it. Yeah, we're going to use the chip. So work this out. If we're thinking that this is pin 1, Doritos chip. Let's see. I mean, I already know, like, it would be so easy for me to tap into the chat and just turn the LED on based on a message. So easy. I need to get this matrix working. Okay, Arduino 8x8 basics. Okay, watch this YouTube video. All right, let's try it. "64 LEDs, 16 pins. Yep, yep, yep. I think they're doing it without the chip, though. Or do they have a chip? And let's see, do they have diagrams? No, they're not using the chip. I want to use the chip because the chip is going to allow us to use Johnny 5 very easily. So we're not going to do that. We are going to... Yeah, I honestly, maybe this is what you meant, Brexis. Get it work. Let's do this. We're gonna get the just basic LEDs working, and then we'll work on the matrix. I will get it working. But let's get. I like this plan. We're gonna get these LEDs. If we get these LEDs working, then we're gonna move on to bigger and better things. The reason I'm not using C++ is because I want to tap into like TMI.js or something, or my backend chat server, so I can use what am I trying to say? So I can use chat. So I can use chat and then integrate with that with the LEDs. Yeah, and the main thing I was thinking was because we're using this expander thingy, Johnny 5 really has like code that you can use for it. Oh, wait. What's the difference between a shift register and an expander? These are the same. Yeah, these are the same. But Johnny 5... Yeah. So someone just mentioned, Krisu is saying, you don't need a shift register if you have 16 free ports. Okay. Yeah, so the Arduino doesn't have any networking. Which is why I want to use something that does. So that way we can control it like through the chat and stuff. Okay, but let's get this circuit working. We're just going to use basic LEDs and use the Arduino. This is the plan. So let's start wiring up. I'm going to move this down here. The shift register is cuter. Okay, that's our circuit. This is our real circuit. I just want to get these both being displayed at the same time. Here we go. So, we need... we already have power and ground. Yes, I do have... This is gonna be a mess. But, right now, I have 5-volt power connecting to my power rail. I'll unplug this for now. That's a 220. And I have ground connected to ground. So power and ground, good to go. Now, we need some LEDs. We'll just use red ones. We're connecting these side by side. So the cathode goes in one, and the anode goes in another. So we'll have one there. Call tech support. And then we have the anode and the cathode. So that one's going to go. Oh, they're skipping one. We'll skip one. So that one goes there. And then this one goes there. And then this one goes there. Okay, so we got our LEDs set up. We do red ones on the other side. So, anode, cathode. Positive is going in that direction. Yeah, people aren't playing the game. I'm okay with disabling it. Gone. That one goes there. No, when did Arduino happen on the coding train? Was that recently? I didn't see a stream recently with that. What mainly inspired it was the fact that I was teaching a class to girls, teaching them how to solder and how to program. Last weekend I did that. Okay, so we got ourselves some LEDs. We now need a bunch of 220 resistors. To make it less messy. Oh, I saw that one. They used Johnny 5 on that one. But I've had just, I mean, you can see this pile of electronics, and you can see down on the floor I have all kinds of things. I've had this stuff for a long time, and I've like messed around with it in various ways for a long time. Okay. I'm going to get some wire cutters so that way this is less messy. $180 chickens. Okay. Have I seen that the LEDs are mirrored on the second row? Yeah. So basically, positive is always going in this direction. So all the left ones are the positive ones, and on this side, all the technically right ones are the positive ones. So yeah. I've got some wire strippers, but here's what I'm gonna do. I'm just gonna make this a whole lot less longer. I'm gonna make it shorter, so some people would say. Cool. Cool. So I've got a tiny, I probably cut this one too much. A tiny little resistor. And this needs to connect to the ground. And it looks like is it connected directly to ground? Yeah, it's connected directly to ground. That's okay. So that we can connect it connect it directly to the ground rail. Take a look at this one. Just identify the orientation. Ooh. Yeah, it's the same one. And they have this. Yeah. I mean, I think we sort of already figured that out. Just the fact that, well, I guess we were assuming which one was pin 1. Yeah. Oh, the pin. You mean like the pin numbers? Yeah. This image or this image? Above that in the right. Above this on the right. I don't know. But I'm still okay with going with this first. I was on. That's fine. I think like, and ultimately, what I'm even going to be able to get done this stream is wiring up this circuit and then controlling that with Johnny 5. I think that's what we got to do, and then I got to do a little bit more research to make sure to figure out how to use this thing. Oh, it makes it look like I have a background. Okay, what were we doing? This. So basically, all these just need to connect to ground. So I might have cut off too much. And hello, Mahidra, welcome. Oh, this should work. Hopefully that's enough. But you can see this one's connected from the anode to the ground rail, so that's good. And then I just need more 220s. Where'd they all go? Oh, here they are. Hello, Crit, who says, I love me some Arduino stuff. Arduino's fun. So, we go from the anode to the ground rail. Wait, that's what it's doing, right? Yeah, it's connecting the resistor to ground. Okay. Keep on moving. Nice. Yeah, mods can use the on YouTube anyways, the custom emotes. And just move my ground wire coming from the Arduino out of the way. So I basically just move those down there to give me some space. Now I wonder how they cramp 1 billion transistors onto a 1mm die. Yeah, I mean, that's how modern processors are created. I'm doing pretty good. We showed the basics of Arduino earlier, and now we've just been messing around. We spent a while just trying to figure out how we might get this thing to work, but I'm at a loss because nobody's really done it the way we're trying to do it before with what I have. Because we have this thing that can control it, but I've never seen I haven't found anywhere that uses Johnny 5 with this and this to control it. So we found a Johnny 5 tutorial to do something like this, which we're going to use the chip for. We're going to get that working, learn how it works, and then in a later stream, potentially like next weekend, apply it to the other LED. Okay. Go from there to the ground. Ground wire. Ground wire. Yep. All right. Yeah, I've never been there. I've always wanted to go to SparkFun. So you might have seen the SparkFun website. They sell electronic parts and stuff, but their warehouse is near like probably a little less than an hour away from me. So yeah, you can literally go to the warehouse and buy stuff if I wanted to. I've never been though. I've always wanted to go. And I mean, what we could do is buy one of these chips that has the thing integrated on it, and that makes it so much easier to program. You literally plug like 4 wires into it, and then the Johnny 5 has a thing for controlling it. But I don't have that, so. Hello, Ruben. I'm streaming on YouTube. What do you mean? Ah, a mail sensor. Send mail when you send a notification when you receive mail. That's pretty cool. Oh man, this thing is bent. I don't know if I'm gonna be able to get it in. Oh, buddy, you stay there. Okay, that went in pretty well. Hmm. I've officially messed up this resistor. The thing is, we don't have to trim them, but they're really gonna get in the way because I'm gonna trim them. At least, well, I won't trim as much. We're gonna go that much. Yeah, Hayward is saying the SparkFun quick cables have really helped me get into Arduino. That's cool. Ground. Ground. Yeah, nice. Very good. All right, we have all the resistors in. That's good. Now we can work on the other side. Get resistors in there. I mean, honestly, I can unplug it from the Arduino for now while we get all this stuff going. So on this side, the ground is here, I believe. Let me just double check. Yes, that's the way I did it. So the ground's on the left of each one. I can definitely trim this more. Circuit diagram on the bottom. If you go to the Johnny 5 website, click on I think tutorials or reference, and then look at led.matrix. Oh no. Let me just link to it. I'll just give you the link. Examples shift register. This is the one. And specifically because we're going to be programming against this chip is why I'm using that example. This one. Yeah. Yeah. So right now I do YouTube and Twitch streaming. I have not switched over to just Twitch yet. And I don't know if I'm going to. What I might start doing, actually, we'll do that. That's good. But what I might start doing is streaming on Twitch on certain days and streaming on YouTube on other days. That way I could enable the monetization stuff. Yeah. A 32 by 32 RGB matrix. That'd be sweet. I might do that eventually, Crit. I just don't have it on my like to-do list anytime soon. Mainly, I'll say this: the main reason I don't do that, is because this chat window currently runs some HTML code that you send to it, right? I'm using a library for purifying things so that to prevent script injection. But right now these are just dumb clients. They're just reading the chat. And the moment I need to integrate sending messages, then potentially some sort of API key is hidden in the browser, right? And Copy link to text. I could add a button. So if I add sending messages, I will most likely need to disable the ability to embed things, just to prevent myself from potentially leaking a YouTube API token or a Twitch token or something like that. That's the main reason I haven't done it yet. Because if this window gets hacked, no big deal. Like, yeah. Heh. So it's an ugly job, but they're all plugged in. It's not as beautiful as the picture, but that's okay. And then what do we do next? Yeah, so we're gonna have to start plugging stuff into the chip. For this scenario, let's put the chip on this side, like right here, across the bridge. There we go. It's nice and plugged in. The notch is at the top, so we know that this is pin 1. We learned that earlier. And in their diagram, the notch is there too. So we need, yeah, the cutout is at the top. I'm going to make this a little bit smaller just so I can see more things. We're going to put that there. We need, pin 1 is going to connect it to this LED's positive. So let's do that. Use an orange wire. So pin 1, which is this one, connected to pin 1, that's going to go to the second LED's positive end, which is going to be, well, in this case, this one, because the way I plugged them in. Right? Yeah, that's positive and negative. That goes there. Cool. And one done. We need another wire. And I can use one of these. So this is multiple wires that are already like connected together. So that'll make things a little bit easier. We then go from pin 2. So that's my blue wire. That's going to go to this bottom one, positive. And then we go pin 3. I'll use the green one. Oh, I did the wrong thing. This one goes to positive. And then pin 3, which is, oh, no, blue, which is pin 2, goes to this positive. Here. And this one goes to this positive. There. Okay. Now, the next pin, pin 4, here, the orange one is going to go to the top right positive. So I'm actually just going to pull this yellow wire off. I can do it like that. Because this one goes to the top right positive end. Okay. The next one, which is this green one, goes to the third one. Positive. Oh. And then blue one here. This leaves us, oh, I messed up somewhere. Orange goes to the top, which is going to be our 4th pin. 1, 2, 3, 4th. Yep, that goes to the top. Good. The next one, which is yellow. Yellow is going to go, well, yeah, no. which is this one. I'm gonna go to the positive here. This one goes to this one. Third one. And then the second to last pin here, that goes to this last one down here. Okay. it's pretty messy circuit, but now we just got to connect this side. So this last pin down here, I don't have anything connected to. That's going to go to ground. Use a gray wire for that. And I'm actually just going to connect that one to this ground rail on this side, because I'm eventually going to connect ground from the Arduino here. So this is ground, and it's connected to all of these. Okay. Let me catch up. And hello, the Cyber Manatee. Welcome. Write a small Vue.js front end to toggle the LEDs? Yeah, I could, because my back end would basically be running Johnny 5, and then we could have a front end that sends messages to it. But yeah. Can we take a moment and appreciate the wireless technology? Yeah. Yeah, this is definitely a building stream. And thanks for the follow, Lobnik. Welcome. You could connect pin 8 to 13 to ground, rather than 2 ground pins. Okay. I think you're meaning these two here, right? There's a ground issue with the left side LEDs in the drawing. Does anyone see that? Yeah, these don't have a ground connected to it, but it should. I think that's the issue that you're talking about. Like, it doesn't show that there's actually any ground being connected. Yeah. Oh, I was gonna do the YouTube chat. The eventuality is we're gonna take this thing, and we're gonna use the live chat, where people can send messages to turn any given LED on and off. But can't quite do that yet, because yeah. Yeah, and I'm gonna connect this ground to this one, then we're good to go, and then I guess this bottom pin down here needs to go to ground as well, I believe. Yeah. So really I need to take this ground and wire it over to this ground, so now all the grounds are connected. Like so. Let's start connecting the other side. So this top left pin here needs to be connected to power, to 5 volts. So top left, we're going to put that in the power rail here. And then we can start connecting the other wires. Technically, I do have smaller wires, so that might have actually helped a little bit. These are a little bit smaller. But let's keep going. So, this pin here goes to the top right one. Need a longer wire for that. So, this pin can go underneath. Goes to the positive over here. It's starting to look like spaghetti. Yeah, it's pretty horrible. We can find some shorter wires, and like especially when we hook. That's why, like, if we could get this working by only plugging into those 8 pins without needing that thing, it would be a really clean connection, because we could go directly from there to the Arduino. Okay, so that one goes there. This blue one gets connected to pin. Well, we're not going to connect to the Arduino just yet. I'm going to get all the other things wired up. 4th pin goes to ground. One, two, three, 4 goes to ground as well. Okay. That goes to the Arduino, that goes to the Arduino. This one gets connected to the power, 5-volt rail. It's the second to last one. Here. It's connected to power. And imagine you buy a CPU and you're just shipped a bag of 6 billion transistors. Spaghetti. Like one of those data center cables. It's fun to look at though, isn't it? Let me make it bigger. Look at that. And I probably did something wrong, which is going to make it all not work. And then we have to debug every single connection. Lower profile wire is way better than jump wire. Yeah, for sure. And I do have some that like keep a low profile where like you just plug them in and they like hug the breadboard. But yeah, looks delicious. Okay, so the diagram doesn't show it, but I believe this one needs to go to ground. Is that accurate? Like there's no wire connecting it. A diagram like that, yeah. Anybody else watching, can you confirm that? So the bottom right pin should be connected to ground, I think. Is that accurate? I don't know. I really don't know. No. It's just connected to nothing? No connection. I guess, did we pull up the data sheet for this thing? Yeah, bottom left is connected to ground, but the bottom right is connecting to nothing. Yeah, this one, yeah, their bottom right one's not connected to anything. I think that's the way to go. Okay. It's for daisy chaining. Okay. If that's the case, then every one of my LEDs is connected. I now need to connect it to the Arduino. Okay. And thanks for the YouTube sub pinpoint. Much appreciated. So we're using digital pins 2, 3, and 4. Let's get a larger wire. Yeah. So the third pin on the right, just this one, gets connected to pin digital 2 in. That one. This is a mess. All right. The next one's connected to ground, and we already did that. Cool. The next one is connected to pin 4. You need a longer wire. Work. So it's the 5th from the top. 1, 2, 3, 4, 5. That's right below ground. Yeah. This goes to digital 4. And see you later, Katoli. Thanks for hanging out with us. We're going to get these LEDs to light up. It's going to be fun. And one more wire. We go from this one to pin 4. Please. Yeah. Oh, that won't work. This doesn't have a pointy end on both sides. It has that. If this works on the first try, that will be amazing. Okay, so from there to pin 3. Okay. And yeah, I don't have power and grounded connected to anything yet. but we'll wire the things up. So power, oh, whole body, and ground. So the stuff's lit up. I don't know why. I don't actually have a program running on this thing yet, but it's probably just, it all has power already. So, all right, we're all hooked up. Now, let's see what we can do. Because we're using a shift register program, so create a board. When it's ready, we create a shift register. Pins on data is 2, clock is 3, latch is 4. So it just keeps cycling these values. Okay. And thanks for the follow, Hewer. Welcome. Here we go. We need these things. So back to, this is our basic LED program, and we're going to get a little more complex. This wants us to basically to destructure board and shift register from Johnny 5. So we can do that. Then we create a new board, which we were doing before. I guess we didn't do that. Like that. I'll just copy this in. Oh, now, so when it's ready, create a new shift register. And this makes a little bit of sense as to how we've plugged it actually into the Arduino over here. So we're on pins 2, 3, and 4. So pin 2 is data, pin 3 is clock, and pin 4 is latch. So those 3 are plugged into the data, clock, and latch of the shift register chip. And then we have some values that we're sending it. And basically, this just runs like in an infinite loop. So it says value. If value is greater than lower, then shift the bits of value. Otherwise, choose upper. And then just call it again. So this should be blinking something on the screen. I don't know what it's going to do exactly, but we'll see. So let's run it. Wow. Okay. So yeah, this is great. So they're lighting up in order, but my bottom left one is not connecting. And I wonder why. Could be a bad LED, honestly. Let's change it. No. Could be a bad resistor connection. Yeah. Let's try. Yeah, because this, you can see this resistor was super tiny. I cut it. Try a different one. But it's working. So that's cool. My mom would definitely be proud. She wouldn't know what she's looking at. She'd probably say it was pretty because of all the wires, but she'd be proud. All right, we need another 220 resistor. Thank you, Doc. All I did was follow a tutorial, but I'm glad that it sort of kind of works. Let's see if putting this newer, better resistor in will fix that bottom LED. There we go. Very nice. That many wires just left. The thing is, we're using we're using that chip to control these. So let's actually like break down what's happening in this code, and eventually that's how we'll get the 8x8 matrix to work. But yeah, Greg says, I went away for 2 hours. I was expecting wings and wheels by now. No, this is very, very basic. The main thing was I probably spent an hour just searching the web trying to figure out how I was going to get this thing to work. Ultimately, this thing is going to plug into this shift register chip. But okay, so really, we're just saying register.send and we're sending a value. So here's the thing. If we send, let's comment all of this out, and I'm just going to say register.send all zeros. It should turn everything off, right? Register.send this value. So if I run this code, though actually, that's 40% of getting the 8x8 working. Cool. So now everything turned off. Do I have access to register? No. There is a REPL though. I can actually just run code in there, right? Whoa. Do I have access to Johnny 5 in here? No, it's literally just a REPL. Okay. So, I mean, honestly, I could just take this code. Oh, maybe not. I thought we were going to be able to use the REPL, but we're not. Okay, but yeah, we sent that. So what happens if I send this? So just a value 1 on the far left. Let's see what happens on the LED matrix. So that lights up this one on the right. And the one right next to it is actually like, it looks like it's kind of lit up, the one, but not all the way lit up. Okay. What happens if we send like this? With a capital B? Let's see. Oh, yes. And then technically that other variable isn't in scope. Okay, regardless. So, no, but then I'd still have to require in shift register. Yeah, let's see. Do that. And then create my register variable like that. And then I should be able to send values to it like this. Let's go bigger. So if I send all zeros, turns off. Cool, we got ourselves a REPL. So the value 1 there lights up that one, though that's not what happened last time. And then the value 1 here lights up the next one, okay? And then the value 1 there, well, in the 4th spot, lights up the 4th one. So basically, each one of these things represents an LED. So we have 8 LEDs. And if we sent all 1s, then all of the LEDs should light up, right? Ta-da! So if I do like the first and the last, then we should see this one and probably this one lit up. Yep. Look at that. Figured it out. So this library is called Johnny 5, and hello Conrad, welcome. So this is a JavaScript library that communicates over serial to the Arduino. So we're writing JavaScript code, but under the hood it's sending serial messages to the Arduino, which in turn is controlling all this stuff. So that's great. Here's what we're gonna do just to get this working, and then I'm gonna stop streaming. In Twitch chat, you can send a message with this string here. And I'm going to take that in and send it to the LEDs. That's what we're going to do. So in this file here, and I'll just make this smaller for now, way smaller, like that smaller. Just going to go right there. In this file, I'm going to install the Socket.io client. Oh, what happened? Did I flip it the wrong way? Yeah, there we go. And thanks for the follow, LOE Face. And there was another follow. What Weasel? Welcome. Thank you. Alert. Kappa. So here's what we're going to do. Kill this. Exit. and we're gonna install socket.io -client, I think. Yeah, socket.io client. Building a self-regulating hydroponic system. No. We just made these LEDs light up. Cool, so we have socket.io client, and what I'm going to do is I'm going to connect that client to my backend server, which has incoming chats from YouTube and Twitch. And you can send a message to control the thing. So now that we have socket.io client, well, TMI would only work with Twitch. I want it to work with YouTube chat as well. And because of that, I'm just using my custom backend server. So we have that going. So when do we program it to be alive? Here's what I need to do, though. I'm going to open up my... really, I could open up my seedling drop game. So the drop game is communicating with the same backend. So we can see how it actually does it. What? So I can look at app. So basically my backend server has a way of getting a list of streams. So we kind of need to do that right here. And then we don't need to do anything with high scores, but this is basically going to get us a live chat ID and a connection to the backend server. So I'll just say IO equals require socket.io client. And then we'll do it on board ready. We'll start listening for things to happen. Well, really, no, we'll do this. We need like a global variable for live chat ID. And then I need to contact my backend API. Let's put this here. Get the live chat ID and then set it so that way we can use it. So we'll create the socket. Really? We'll just do this when the board is ready. Because then we can make this an async function and like do whatever we want in here. So it's all within scope. So this is an async function. We're going to connect to my backend server, which is currently just localhost port 5000, I think. I'll double check that. So we connect to the backend, and then I need to get the live chat ID. Which is going to be the server URL. So that. Then we can reuse it. The fact that Fortune just printed out something about Denver on a wait, did it? I didn't see it. Denver, a smallish city located just below the O in Colorado. That's funny. I've never seen that one before. Okay, so we grab it. We should get back the live chat ID, and then we can listen for messages. I don't get it. If you look at a map of Colorado, I'm sure like if you put, and it has the like it's labeled as Colorado, it's right below the O. I don't know. Okay, and then we need to listen for messages. So literally all I do is socket.on that live chat ID. There's a lot of O's in Colorado. Oh. I don't know. Maybe I don't get it. I just laughed anyways. So I think this is it. I need to confirm that that's where my backend chat server is living. Yeah, port 5000. Cool. So this should do it. Now, when I start up my Arduino code, it should show messages incoming from the chat. Oh, buddy. On handle, fetch is not defined. Okay, I need node fetch. Hello, Atomic J. Oh, I need to actually require it in. There you go. So nothing's gonna happen. Oh yeah. So we it starts up. It does send a message. Yeah. And if people send messages, we can see that we're actually connecting to my backend chat server. So we can do something based on it. There you go. I'm not using it just yet, but we are getting the messages. So what we can do is when we get a message. If the message matches a particular thing. So basically, this is the string that we need to send to the PCB, not to the PCB, to the shift register to turn things on or off. So if the message begins with like exclamation mark LED or something, we'll do that. Okay, so I just cut creating a register. We're gonna create the register here. Not really a string, it's a number. This is true, but the message is going to be a string. And we're going to say if message.message, I think it is. Message.message, yeah. Dot starts with LED. And we'll do the thing. And then we'll say let's call it the command, I guess. Is going to be message.message.split on a space, because ultimately you're going to say exclamation mark LED, parse a binary number. We could do that, I guess. Yeah, we're sending an 8-bit binary number though. I'm not going to just parse it. We're going to verify it. We're going to look at like each individual digit. Oh no, I see. We do need to parse it as a binary number. Regex the whole message? I don't know. This is not quite right, though. This is going to be the string message. We'll call it that. So split it on the space, grab the first one, and then I need to validate it. Yeah, so, and that's eventually the plan. Like, eventually we're going to use something like this, and then the chat can turn on or off one individual LED. Yeah, it should be message.message though, because that's the actual text of the message. So we're going to grab the command at 1, and then we're going to, no, really, I could just pass the command in here. This is a 2015 MacBook Pro. Parse int and make sure it's 0 to 255. I'm gonna look at each bit. That's all I'm gonna do. So the message you send has to look like this. So I'm gonna say if valid command with that command. We'll do this, and then we'll just send it like that. And validate the length. Yeah, so I'm going to create this function called valid command. It's going to take in a string. Let's put this, for now, let's put this like over here. It needs to look something like this. I'm just going to do like a simple for loop that looks at each individual value. So we'll say if command.length is equal to, it needs to be 8, it needs to be length 10. So if it's not length 10, it's no good. If command at, and also, I mean, it's going to always be a string because of this, but if command at 1, so if we're looking at this as an example, 1 needs to be a lowercase b. Is not equal to lowercase b, return false. Mod 256 final answer? No. Because the thing is, it comes in as a string. I'm just going to look at each individual digit. So make sure it's length 10. Make sure the second thing is a b. Make sure the first thing is a 0. And then we can look at all the other digits and make sure they're 0 or 1. And so we can do something like command.slice 2, so get rid of the first 2 things. And it'll start 0, 1, 2. And every digit is equal to 0 or 1. We can use triple equals. Like that. So first, validate the length. Validate the first 2 bits. Technically, they're not bits. Like 0b, I believe, is how you represent binary in JavaScript code. But regardless, it's going to be a string. So make sure it's 0b. I could say starts with 0b. Yeah, let's do that. So if the command does not start with 0b, return false. And then I want to return, get rid of the first 2 character. Oh no, I need to, does that work? I think that works on a string. Yeah, so that returns the rest of it. So slice it. But then I need to turn it into an array to use the everything. Every digit is equal to 0 or 1. Great. I do not like the terminal in VS Code. I never have. I don't think I ever will. So what we did was we have this running in Johnny 5. So you can send the a series of bits to the register, which will turn on any one of these LEDs. So this is bit 0, 1, 2, 3, 4, 5, 6, 7, 8. So yeah. And yeah. So if it's valid, it's going to send it. I guess we should do a timeout for a given person. So I like Kitty. Each message has an author channel ID property. And you can only send a message, let's say like once every 10 seconds. Let's do this. Users. Just going to be a little object. And then whenever you get a message, if it's a valid command, we're going to put them in there. So we'll say users at message.author.channel ID equals true. So if it was a valid command, we register it. And if the user is in there, you don't get to set it again. But then we'll remove you from this after, I don't know, 30 seconds. Like that. All right, this is it. This is just gonna work. So, I think one thing I'll do is I need to log out what got parsed. So we're gonna log the command. So we get message.author.displayname, and then their command. And then I'll also log the value that gets parsed. Let's do this. The actual command is going to get parsed into an integer, and then we send that. Okay. So the command is, I'll send you a quick example. So exclamation mark LED, and then 0B followed by 8 bits. Not yet. All right, so it's running. You can try. There we go. So Xmetrics just turned everything off. Oh, they're coming in too fast. And also, it's parsing everything as 0. That's not good. Do we need? I think we might need to get rid of the 0B at the front. Yeah, you can stop now. It's broken. The parse int, it should only work with, I'm sending in the full string. Just accept 8 digits from users. I guess I'll do that. So, it doesn't have to start with 0b. It needs to be length 8, and everything needs to be a 0 or a 1. And parse int, I think parse int didn't want it to start with the 0b, like, or like that should be 8. Yeah, so that should do it. This was what was throwing it off because it started with 0b. Yeah. Okay, this should do it. Try now. That's pretty cool. So, time for coffee was the last message that came through. Yeah, there we go. So Doc did 255 and they all lit up. So I think that's a good thing. Atomic J did 83, 85. So this is technically 0, 1, 0, 1, 0, 1, 0, 1. Yeah. And then 85 is, well, that would have turned that one on. Cool. And this is 1, 0, 1, 0, 1, 1, 1. It's working. It's blinking lights. My mom would definitely be proud of me. I think so. Nice. So the value 15 is 0, 0, 0, 1, 1, 1, 1, 1. A 1 second. Yeah, we can do that. We could create a queue of changes. So that way they instead of like changing initially, blinking lights. That's true, Xmetrics. Good call. And Neko Bakasan just turned everything off. A small bug in my validate function? It's possible. But yeah, let's do this. You can send root access granted. I'm gonna queue up the changes so that way they don't you can't overwrite someone else's changes. So here's what we'll do. We'll have just like an array of values that's initially empty. And when we receive a valid one, we're going to, instead of just doing register.send, we're going to push it into the value. So we'll say values.push value. And then I'm just going to have something running on an interval to check to see if there are any values left. So probably just like right in here. So this is going to be running, let's say every 2 seconds. We'll say if values.length. We'll say value is values.shift, which should get the first element in the array, which is the last one we need, or the oldest one. So shift, and then we'll do register.send value. And this will happen every 2 seconds. Though technically, I could push all of this in to see all of it. I think I'm gonna do that. So we're just gonna push an object in that has all of these things. So that way I can log it down here. Well, we can destructure it. We can pull off the name, the command, and the value. So here we'll just log name, command, value. There we go. I haven't restarted. I need to restart, but once I restart, it'll start queuing up commands. So Terrazoid sent 000s. Here we go. And then there's Docs. And then there's Timothy Sheck. And then there's Acid Spark. And then there's Polar Fluke. And it should wait 2 seconds between. Yeah, so multiple just came in. So there's Terrazoid. I think Time for Coffee, you sent too many. Yeah, so it should wait 2 seconds in between. That's cool. And thanks for the follow, UST3. Yeah, so it waited a second before it switched to a light years away's message. So that's cool. All right, I think we're done for today. This was super fun. And it works, sort of. I mean, I think this is a good compromise to not being able to hook this thing up, because in the future, it's going to get even cooler. So, yeah, queues are pretty simple. So basically, we fill that array up. Every 2 seconds, we remove the first one from the array. And then we just keep doing that every 2 seconds. And if there's anything left, we just pull the latest one. A 64 by 64 RGB. Yeah, that'd be cool. We could show some really cool stuff with that. But I think we're going to start small. We're going to start with this. Basically, we can use this with the shift register chip that we plugged up. And we'll make it so that chat commands are like, you specify the row and the column of the LED that you want, and that thing will turn on. All right, I'll turn the drop game on. Look at all those drops. A macro LEDs display with clusters of RG and B LEDs. That would be pretty cool, huh? So we take a red, a green, and a blue. And from far away, this might actually work. Well, actually, because yeah, you could use pulse width. You could do something like this, RGB, and then you could use pulse width modulation to control the brightness of each one to determine what's the color of that pixel. Yeah, I don't know. Probably not going to do that. This was fun though. This was fun. Next time, I think maybe we'll make this a Sunday thing. So like, every Sunday we'll do some hardware stuff. After 8x8, let 8x8 flippy dot? What? So this is 001001. Pretty cool. Pretty cool. All right, that's it. I'll share this code. The code isn't that complex, and honestly though, the code is specific to my backend chat server. So that's a little weird. But technically, you could do the same thing with TMI.js. So instead of using socket.io to connect to a server, use TMI.js to connect to a Twitch channel, and then the logic is fairly similar in here for like a Twitch channel. Yeah. All right, movie night? At some point, I don't know. All right, let's find someone to raid. We can make this small, a little bit smaller. And see you later, Win320 Day. Shout out to Win320 Day. They're definitely providing some tips and tricks and help in the chat throughout this stream, so much appreciated. Yeah, thanks for hanging out, Atomic J. Let's find somebody to raid. Oh, is Lab424 on? That's so perfect. We mentioned them earlier. So he has like a big LED matrix, and like RGB LED matrix, that you can actually control from the chat. Yeah, this thing back here. So his is legit. Mine's nothing compared to his. So yeah, let's raid Laboratory 424. That'll be a good time. So if you're watching on YouTube, head over to twitch.tv/codinggarden. YouTube. Here you go. So head over to Twitch. We're gonna do a good old-fashioned raid. Let's get that raid message ready. And thanks for the follow, Neko Bakasan. Welcome. Oh, you sent a seedling? Nice. Nice. All right, so this is our raid message. There we go. Copy and paste that. We're gonna do a good old-fashioned raid. Thanks to everyone for hanging out with us. This was super fun. Super fun. So here we go. Oh, that's the wrong thing. Laboratory 424? Is that the right thing? There we go. That is the right thing. All right, be sure to copy and paste that raid message. We'll send that when we go over to their stream. And thanks for watching. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.